Beneath the surface of our oceans lies a world so vast, so alien, that even our most advanced technologies have barely scratched its surface. Down there, in the crushing dark, time seems to stand still, preserving secrets older than civilization itself. Strange lights flicker where no sun has ever reached. Creatures with translucent bodies drift silently through waters colder than ice. And every so often, something stirs, a sound, a shape, a signal, unexplained, unrepeatable, unbelievable. Despite centuries of exploration, over 80% of our oceans remain uncharted. What lurks in those black depths? Why do some signals from the deep resemble no known life form or machine? Why have certain shipwrecks vanished entirely from the sea floor, without a trace? These are not tales of fiction. These are the real mysteries that have left scientists puzzled, explorers humbled, and our understanding of Earth incomplete. So if you think you know this planet, think again. Sit back, relax, and let's dive deeper into the unknown. This is 3+ hours of deep-sea mysteries science can't explain. Far beneath the turbulent surface of the South Pacific Ocean, where sunlight fails to penetrate and pressure crushes with relentless force, lies one of the most enigmatic mysteries of the deep sea. A sound so vast, so powerful, it has perplexed scientists for decades. This is the story of the BLOOP, an audio anomaly that continues to echo through the halls of marine research, haunting experts and inspiring endless speculation. The sound was first detected in 1997 by the National Oceanic and Atmospheric Administration, NOAA, using an array of underwater microphones, hydrophones, spread across thousands of miles of ocean floor. Designed initially to monitor submarines during the Cold War, these devices unexpectedly recorded something entirely different. An ultra-low frequency sound, louder than any known marine animal could produce, and unmistakably organic in its characteristics. The bloop was a sequence of sounds that rose rapidly in frequency over about 1 minute. It was so powerful that it was picked up by sensors more than 5,000 kilometers apart, indicating the source was enormous, or extraordinarily loud. This baffled scientists. What creature or natural phenomenon could generate such a deep, resonating call? The ocean is full of strange sounds, from whale songs to volcanic activity, but the bloop stood apart, almost unlike anything documented. Many theories arose quickly to explain the bloop's origin. Some suggested a giant marine animal far larger than the blue whale, the largest creature known to exist. Others pointed to geophysical events such as underwater ice quakes or volcanic eruptions that might have produced the sound. Yet none fit perfectly. The sound's tonal pattern resembled the vocalizations of living creatures, complex and dynamic, not a mechanical or geological noise. The location of the bloop's source added another layer of intrigue. It was traced to a remote area near Antarctica's Ross Ice Shelf, a place largely unexplored, cloaked in ice and darkness. This area is infamous for its mysterious and extreme conditions: floating icebergs scraping the ocean floor, shifting glaciers, and deep underwater canyons. Could an unknown creature survive here? Hidden from human eyes? Capable of emitting such an otherworldly call? In 2005, NOAA scientists offered a more conventional explanation. They proposed that the bloop was caused by the fracturing of icebergs as they scrape against the seabed, a phenomenon known as ice quakes. These events generate loud, low-frequency sounds that can travel thousands of miles underwater. While this explanation fits well with the environmental conditions near Antarctica and the sound's acoustic profile, it does not fully account for the apparent organic quality embedded in the bloop's signature. This gap between data and explanation has left room for speculation and wonder. Some researchers, reluctant to dismiss the possibility of undiscovered life forms, speculate that the bloop might be the call of a colossal, unknown species living in the ocean's abyssal depths. After all, the deep ocean remains one of the least explored frontiers on Earth, a world where new species are still regularly discovered. Could there be a creature so immense, so enigmatic, that it has eluded all our attempts at observation? Marine biologists remind us that the ocean's depths, especially near the poles, have yielded surprises before, from giant squid caught on film to bizarre bioluminescent animals that challenge our definitions of life. Yet, the ocean's secrets may not be biological alone. Some suggest that unknown geological processes, perhaps unique to polar underwater environments, might create sounds mimicking living creatures. Ice shelf dynamics are complex and poorly understood, with layers of ice interacting with cold, dense water in ways that could produce strange acoustic phenomena. The bloop, therefore, sits at a crossroads between biology and geology, fact and mystery. It challenges our understanding of the ocean's depths and forces scientists to reconsider the limits of their knowledge. What is certain is that the bloop sound itself is real, recorded, and persistent in the scientific archives. It remains one of the loudest underwater sounds ever recorded by human instruments. And yet, despite years of study, its source remains elusive. As technology advances, new explorations and deep-sea missions continue to push the boundaries of oceanic discovery. Autonomous underwater vehicles, sophisticated sonar arrays, and remote-operated submarines are slowly unveiling the landscape beneath the waves. Yet, even with these tools, the vastness and hostility of the deep sea impose immense challenges. Could future missions finally solve the bloop's riddle? Or will it remain one of the ocean's many enduring enigmas, a sound that beckons us toward the unknown? For now, the bloop remains a haunting reminder of how much remains unseen and unheard beneath the surface, a mystery that invites us to listen closely, to the ocean, to science, and to the whispers of the deep that defy explanation. What lurks in those uncharted depths? What ancient and powerful forces or creatures await our discovery? The ocean keeps its secrets well, and the bloop is perhaps its most compelling call. As the mysterious echoes of the bloop fade into the vast silence of the deep ocean, our journey takes us to another enigmatic inhabitant of the abyss, the colossal squid. A creature as elusive as the sound that once puzzled scientists, the colossal squid has long been a symbol of the unknown lurking beneath the waves. It is a giant among giants, a predator from the darkest depths, whose very existence challenges our understanding of life in the ocean's most forbidding places. The colossal squid, Mesinicoteuthis hamiltoni, dwells primarily in the frigid, deep waters surrounding Antarctica. It is a behemoth, estimated to reach lengths up to 14 meters, making it one of the largest invertebrates on the planet. Its immense size is rivaled only by its almost surreal anatomy. Eyes as large as dinner plates, arms lined with swiveling hooks, and a mantle that pulses silently in the near-freezing darkness. The colossal squid is built for a life of stealth and power, navigating an environment where pressure is immense and light is nearly non-existent. Yet, despite decades of study, much about the colossal squid remains shrouded in mystery. Unlike many marine creatures that surface or are frequently caught in fishing nets, the colossal squid's habitat lies at extreme depths, often between 1,000 and 2,000 meters, making direct observation rare and difficult. Most of what scientists know comes from specimens accidentally caught by deep-sea fishing vessels or recovered from the stomachs of sperm whales, its natural predator. These glimpses into the colossal squid's life have raised as many questions as answers. For instance, how does such a large creature navigate the abyssal plains so effectively? How does it locate prey in the pitch-black ocean? Some behaviors observed or inferred from captured specimens challenge expectations. The colossal squid's enormous eyes are thought to be an adaptation to detect faint bioluminescent light from potential prey or predators, yet these eyes seem almost disproportionately large even for such an environment. Moreover, the squid's hunting tactics are still largely speculative. Its arms and tentacles are armed with sharp hooks, which could be used to capture slippery prey such as fish and smaller squid. But how does it coordinate such hunting in the near-total darkness? Does it rely on senses beyond our current understanding, such as electroreception or some form of sonar-like perception? And what of its encounters with sperm whales, titanic battles witnessed only through the scars and remnants left on both combatants? One of the most intriguing aspects of colossal squid behavior is what remains unseen. Unlike many cephalopods that exhibit complex behaviors, color changes, intricate mating rituals, even problem-solving skills, there is almost no direct observation of the colossal squid's life cycle, social structure, or even reproductive habits. Scientists can only piece together hints. Mature females have been found with large egg sacs, but where and how they spawn remains a mystery. Is their life solitary, or do these giants roam in groups? Do they migrate vertically through the water column, or remain in constant depth? These questions remain open, awaiting future exploration. Adding to the enigma are reports from fishermen and researchers who have encountered colossal squid carcasses exhibiting unusual traits. Some specimens display peculiar wounds or markings that cannot be easily explained by known predators or natural causes. Could these be signs of interspecies combat, or perhaps evidence of a previously undocumented behavior or predator lurking even deeper? The ocean, after all, is vast enough to conceal creatures and phenomena far beyond our current comprehension. Speculation also extends into more unconventional territories. Some marine biologists and enthusiasts wonder if the colossal squid might possess unknown sensory abilities, or even forms of communication we have yet to detect. Could these creatures use low-frequency sounds, similar to those recorded in the BLOOP, as a means of long-distance communication or echolocation? Or perhaps bioluminescence plays a larger role in their behavior, not just for hunting, but also for attracting mates or deterring threats. Others contemplate the colossal squid's evolutionary history, which is as mysterious as its present. How did such a massive predator evolve in the isolated extreme environment of the Southern Ocean? What ancient lineage does it represent, and how has it adapted to survive in conditions that would crush lesser beings? Its physiology suggests a creature perfectly honed for a world few humans will ever see, but the evolutionary story is incomplete. What we do know is that every encounter with a colossal squid, whether through a tangled net or a whale's stomach, provides tantalizing fragments of a life lived in profound secrecy. Each new specimen raises questions about the unknown behaviors that could redefine our understanding of deep-sea ecosystems. In recent years, efforts to observe colossal squid in their natural habitat have intensified. Remote-operated vehicles equipped with advanced cameras have captured rare footage, though sightings remain brief and fragmented. These glimpses reveal a creature capable of both swift bursts of movement and languid drifting, an apex predator adapted to the extremes. But the vast majority of its life remains hidden, out of reach, out of sight, and shrouded in darkness. The colossal squid stands as a testament to the ocean's enduring mysteries. It embodies a world where the line between science and speculation blurs, where each discovery uncovers deeper questions. Is the colossal squid a solitary hunter, a silent giant roaming endless depths? Or does it partake in behaviors and interactions still beyond human knowledge? What secrets lie locked within its massive, ink-dark body? As with the BLOOP, the colossal squid invites us to confront the limits of our understanding and to embrace the unknown. It is a living mystery, a giant shadow beneath the waves, reminding us that even in the age of technology and exploration, the ocean guards its secrets closely. What will future expeditions reveal? Will we one day witness the colossal squid's life firsthand, unveiling the behaviors that have puzzled generations? Until then, the deep sea holds its breath, and so must we, watching and wondering at the colossal squid, a marvel of nature still waiting to tell its story. Beneath the enigma of the colossal squid, a broader, even more perplexing phenomenon commands the attention of scientists and ocean explorers alike. The curious reality that in the deep ocean, creatures grow far larger than their shallow water counterparts. This phenomenon, known as deep-sea gigantism, is a profound and mysterious feature of the abyssal world. It poses a question as vast as the ocean itself. Why is everything bigger down there? In the perpetual twilight and crushing pressures of the deep sea, where food is scarce and conditions harsh, one might expect life to shrink, conserve energy, and adapt to survive in smaller forms. Instead, the opposite often happens. Crabs the size of dinner plates, amphipods large enough to rival small rodents, and jellyfish with tentacles stretching for meters reveal a world where nature seems to rewrite its own rules. Scientists have observed deep-sea gigantism in many different species across various taxa, from crustaceans and mollusks to certain fish and even some worms. The reasons behind this remarkable growth have intrigued researchers for decades. One widely accepted explanation relates to the slower metabolism caused by the cold temperatures and limited food supply at such depths. A slower metabolism might result in longer lifespans, allowing organisms to grow larger over time. But is this the whole story? Another factor may lie in oxygen availability. Deep, cold waters hold more dissolved oxygen, potentially supporting larger body sizes. But again, this does not fully account for why gigantism is so pronounced and widespread among deep-sea creatures, especially considering the limited resources they face. Some creatures grow large, seemingly at the cost of agility and speed, yet their size offers survival advantages, such as deterring predators or enabling the capture of larger prey. The evolutionary origins of deep-sea gigantism also remain a subject of ongoing investigation. Are these creatures descended from shallow water ancestors that grew larger to adapt to the new pressures and conditions? Or do they represent ancient lineages that have long thrived in isolation, evolving toward gigantism over millennia? The fossil record, sparse as it is for deep-sea organisms, provides tantalizing but incomplete clues. But even as science offers plausible mechanisms, the mystery deepens when we consider some unexplained observations. For example, some of the largest deep-sea creatures defy conventional biological limits. The giant isopods found at great depths can reach sizes far beyond those of their shallow relatives, seemingly unbounded by the constraints that limit most crustaceans. Likewise, the elusive giant squid, closely related to the colossal squid, has captivated imaginations with its titanic proportions, up to 13 meters or more in length, raising questions about what ecological niche could support such growth. Speculative theories propose that the immense pressures and stable, low temperatures of the deep ocean create an environment where larger size is more feasible or even necessary. Some suggest that gigantism may help conserve energy in a habitat where movement is costly and food sources sporadic. Larger animals may better withstand the cold or better exploit the rare, but large food falls that drift down from the upper ocean. Whale carcasses, for instance, becoming floating islands of life in an otherwise barren expanse. Others consider the role of isolation and slow reproduction rates, arguing that in such an extreme environment, growing bigger is simply a different evolutionary strategy. It may be a way to endure long periods of scarcity, or a means to dominate limited resources and minimize competition. Yet, how these strategies interact with each species' unique biology remains largely unknown. Intriguingly, deep-sea gigantism sometimes crosses into the realm of the seemingly impossible. Anecdotal reports from deep-sea explorers describe encounters with enormous, almost alien-like creatures whose size and form challenge our taxonomies and scientific expectations. While many of these accounts remain unverified, they underscore the ocean's vastness and the limits of human knowledge. The phenomenon of deep-sea gigantism also forces a reconsideration of ecological balance in the deep ocean. What does it mean for the food web when creatures are so large and live so long? How does this influence the cycling of nutrients and energy? And importantly, how might these enormous creatures be affected by climate change, ocean acidification, and human encroachment into previously untouched depths? What role does gigantism play in the broader mystery of ocean life? Does it hint at unknown evolutionary pressures or undiscovered ecosystems deep beneath the waves? Or might it be a natural adaptation we have yet to fully grasp? A testament to life's resilience in one of Earth's most extreme frontiers. As we continue to explore these depths with advanced technology, each discovery brings us closer to understanding. Yet, with every new find, the deep sea seems to grow even more mysterious. For now, the question remains, why is everything bigger down there? The answer is part biology, part ecology, and part mystery, an invitation to keep searching the shadows of the abyss. What secrets do these giants hold? And what other astonishing creatures might still be growing, hidden in the cold, crushing depths? Beneath the vast, dark expanse of the ocean, legends swirl like mist. Tales of colossal serpents, enormous creatures that glide beneath the waves, evoking awe and fear in equal measure. Sea serpents have been part of maritime lore for centuries, whispered among sailors, sketched in old maps, and recorded in countless eyewitness accounts. But are these tales merely myths born of imagination and fear? Or could they hint at real creatures lurking beyond our understanding? The idea of a sea serpent is simple yet profoundly evocative. A long, sinuous creature, sometimes described as hundreds of feet in length, undulating through the water with immense power. Descriptions vary. Some speak of enormous serpentine bodies, with scales glinting in the sun. Others describe massive appendages or rows of spines breaking the ocean's surface. Sightings often occur during storms or in remote waters, where visibility is poor and fear is high, adding to the mystery. Historically, sea serpent reports span the globe. From the fjords of Norway to the coasts of New England, accounts have emerged over centuries. One of the earliest well-documented encounters took place in 1848 off the coast of Norway, where multiple witnesses observed a massive, undulating creature for several minutes. Similarly, in the late 19th century, a series of sightings off the coast of Australia rekindled interest in these enigmatic beings, with eyewitnesses describing long, flexible forms rising and dipping beneath the waves. These accounts, recorded with surprising consistency, challenge simple dismissal. Yet, for centuries, the scientific community has sought rational explanations. Could these sightings be cases of mistaken identity, optical illusions, or misinterpretations of known marine life? Among the leading candidates are giant oarfish, slender, ribbon-like fish that can grow up to 11 meters long. Oarfish undulate through the water with a graceful, serpentine motion, often near the surface, and their shimmering silver bodies catch the light, easily inspiring awe and confusion. Sightings of oarfish have historically coincided with reports of sea serpents, lending credence to the idea that nature itself might be the source of these legends. Similarly, basking sharks and whales can create the illusion of multiple humps or a long, undulating body when surfacing, especially in choppy seas. Large groups of animals moving in unison can also appear as a single serpentine creature from a distance. Yet, these explanations, while plausible, cannot account for every report, particularly those describing animals behaving in ways unlike known species, or those seen in unusually remote or deep locations. More intriguing are the reports involving bioluminescence, glowing lights trailing through the darkness, sometimes described in patterns inconsistent with known creatures. Could there be deep-sea organisms or undiscovered species capable of producing these eerie displays, reinforcing the image of a mythic serpent? The mystery deepens when we consider cultural influences. Sea serpents have permeated folklore across diverse societies, each adapting the story to local environments and beliefs. Were these universal archetypes inspired by a collective human response to the unknown depths, or might they be rooted in real, but rare, encounters with creatures humanity has yet to catalog? Some researchers have even proposed that remnants of prehistoric marine reptiles, like plesiosaurs, might have survived in the ocean's depths, giving rise to modern sea serpent stories. While the fossil record offers no direct evidence for such survival, the sheer vastness and unexplored nature of the deep ocean leave room, however slim, for extraordinary possibilities. Technological advances have provided new tools to investigate. Sonar scans, underwater cameras, and deep-sea submersibles now explore areas once unreachable. Yet, despite these efforts, no definitive proof of sea serpents has surfaced. This absence of evidence leads many scientists to caution against overinterpretation of anecdotal accounts, suggesting that natural phenomena and human perception play a larger role than unknown creatures. Still, some unexplained incidents persist. Odd recordings of underwater sounds, strange shapes caught fleetingly on camera, or unidentifiable carcasses washed ashore continue to fuel speculation. Could these be signs of undiscovered marine life forms, or simply anomalies awaiting explanation? The sea serpent mystery challenges us to confront the limits of our knowledge and the nature of evidence itself. It asks, how do we balance skepticism with wonder? When does a legend hint at truth, and when is it the product of human imagination grappling with the unknown? As we peer into the ocean's depths, we are reminded that the boundary between myth and reality often blurs beneath the waves. Sea serpents, whether figments, misidentifications, or genuine enigmas, invite us to keep searching, questioning, and listening to the whispers of the deep. What truths might still be hidden beneath the surface, waiting for discovery? The ocean's greatest mysteries remain unsolved, calling us to wonder what lies just beyond our sight. Emerging gently from the shadowy depths of the ocean, the giant oarfish glides with an otherworldly grace. Its elongated, ribbon-like body, shimmering silver and occasionally streaked with vivid red fins, can stretch over 10 meters in length, a serpent of the deep that has long captivated human imagination. Often glimpsed near the surface only after being disoriented or sick, these mysterious creatures appear like ancient messengers from a world mostly unseen. But could there be more to their appearances than mere chance? Could the giant oarfish, with its elusive presence, be signaling events far beyond the ocean's realm? Known scientifically as Regalicus glesna, the giant oarfish holds the title of the longest bony fish alive. It inhabits deep ocean waters, sometimes descending to depths of over 1,000 meters, yet occasionally ventures near the surface, often in ways that puzzle scientists and fishermen alike. Sightings are rare and fleeting, usually occurring after turbulent weather or seismic disturbances. Their graceful, undulating swimming style, combined with their vivid coloration and imposing length, has inspired legends across cultures, sometimes depicting them as sea serpents or harbingers of misfortune. For centuries, these creatures have been wrapped in mystery. Fishermen along the Pacific coasts of Japan and the Americas have reported finding oarfish washed ashore or caught in nets following significant earthquakes or tsunamis. Such accounts have sparked speculation that the oarfish might possess a sensitivity to seismic activity, acting as an early warning system for natural disasters. Scientific evidence supporting this hypothesis remains scarce but intriguing. Some researchers propose that oarfish live near tectonic fault lines or in areas prone to seismic disturbance. Their deep habitats are often close to the ocean floor, where the earliest tremors might be felt. Is it possible that the oarfish detect subtle changes in water pressure, magnetic fields, or chemical composition preceding earthquakes, prompting them to ascend to shallower, more visible waters? While no direct proof confirms this seismic sensitivity, the timing of many oarfish strandings and sightings often aligns suspiciously with seismic events. These correlations fuel both scientific curiosity and public fascination. But how do we interpret this? Are the oarfish truly sentinels of the deep, responding to the Earth's shifting crust? Or are these patterns coincidental, the result of natural cycles or other environmental factors influencing their behavior? To better understand, we must consider what is known about their biology and ecology. Oarfish are solitary and elusive, spending most of their lives in the mesopelagic zone, often called the twilight zone of the ocean, where sunlight barely penetrates. Their diet consists mainly of small fish, krill, and squid, captured using a specialized feeding method involving their protrusible jaws. Their movements are generally slow and deliberate, but when disturbed or ill, they may swim erratically or surface unexpectedly. It is precisely this unusual surfacing behavior that has sparked the earthquake connection. When sick or nearing death, oarfish are more likely to be found near the surface or stranded on shores, where they become visible to humans. Could seismic activity trigger physiological stress or disorientation, pushing these deep dwellers out of their usual habitat? Or does some other environmental factor, such as changes in water temperature, currents, or chemical shifts, play a larger role? Some scientists caution against drawing quick conclusions. The ocean is a dynamic and complex environment, and animal behavior is influenced by numerous interacting variables. The occurrence of an earthquake and an oarfish sighting in proximity may be more a reflection of overlapping timelines than cause and effect. Still, the notion that oarfish might sense earthquakes taps into a broader question. How do marine creatures perceive and respond to Earth's subtle signals? Unlike humans, many marine species have evolved to detect vibrations, electromagnetic fields, or chemical changes imperceptible to us. Whales use sonar to navigate and communicate. Sharks sense electrical currents to hunt. Could the giant oarfish possess unknown sensory mechanisms finely tuned to tectonic shifts or other natural phenomena? Beyond biology, cultural traditions add layers of meaning to the oarfish's mysterious appearances. In Japan, the oarfish is called the messenger from the sea god, a harbinger of impending earthquakes or tsunamis. Folklore portrays their arrival as ominous, but also as a warning, an invitation to heed nature's signals. Such narratives reflect a human attempt to interpret and connect with the unknown forces shaping our world. Scientific advances offer new ways to investigate these questions. Oceanographic sensors, underwater drones, and remote cameras now provide glimpses into the deep-sea environments where oarfish dwell. Yet, even with modern technology, the behavior of these elusive giants remains poorly understood. Every sighting yields valuable clues, but many mysteries persist. What triggers their occasional journeys to shallower waters? How do environmental changes, both natural and human-induced, impact their lives? Could the giant oarfish's deep-sea habitat act as a natural seismograph, capturing vibrations and changes undetectable on land? If so, what might their movements reveal about the hidden dynamics of the ocean floor? And could understanding these signals one day contribute to earthquake prediction or disaster preparedness? As we ponder these questions, the giant oarfish continues to glide silently through the twilight depths, a living enigma bridging the gap between oceanic mysteries and terrestrial events. Its appearances, rare and fleeting, invite us to reflect on the complex interplay between Earth's geological forces and the creatures inhabiting the depths. The ocean remains one of the least explored frontiers, where nature's rhythms unfold beyond our senses. The giant oarfish, a slender titan of the deep, reminds us of how much remains hidden beneath the surface, urging caution and curiosity as we seek to decipher its silent messages. What truths might these elusive giants hold? Are they truly harbingers of Earth's subtle tremors, or simply magnificent creatures caught in nature's unpredictable dance? The answer lies somewhere beneath the waves, waiting patiently for us to discover. From the depths of the ocean's endless blue emerges a creature as delicate as it is extraordinary: the immortal jellyfish. At first glance, it appears fragile, almost ethereal, a translucent, bell-shaped body with slender trailing tentacles drifting gently in the currents. Yet beneath this delicate exterior lies one of the most baffling biological mysteries known to science, a creature that, under certain conditions, seems capable of defying death itself. Known scientifically as Turritopsis dohrnii, the immortal jellyfish challenges our fundamental understanding of life and mortality. Unlike most animals, which age, weaken, and eventually perish, this small jellyfish possesses a remarkable ability to revert its cells back to an earlier stage of development, essentially restarting its life cycle. This biological reset button grants it a form of potential immortality, making it one of the only known creatures capable of avoiding the irreversible process of aging. Discovered relatively recently in the late 20th century, the immortal jellyfish quickly captivated biologists and the public alike. Found in oceans around the world, typically in warm, shallow waters, it remains small, rarely exceeding a few millimeters in diameter. Yet its microscopic size belies the profound implications of its unique life cycle. The process begins when the jellyfish reaches maturity. Instead of aging in the usual sense, when faced with environmental stress or physical damage, it transforms its cells through a process called transdifferentiation. Essentially, the jellyfish's specialized cells revert to a more primitive, stem cell-like state, and then develop anew into different types of cells, rebuilding the jellyfish's body from the polyp stage. This cycle of rejuvenation can, theoretically, repeat indefinitely, a phenomenon that hints at a biological fountain of youth. Yet, as astonishing as this sounds, the immortal jellyfish is not truly invincible. Predators, disease, and environmental factors still pose threats that can end its life, but its capacity to escape death by old age, at least in laboratory settings, remains a profound biological anomaly. Scientists continue to explore the molecular and genetic mechanisms behind this ability. What triggers the transformation? How do the jellyfish regulate such a complex process? Could understanding these mechanisms unlock new avenues for human medicine or aging research? These questions linger at the forefront of biological science. The immortal jellyfish also raises philosophical and ethical inquiries. What does it mean to be truly immortal? Could such a process exist in other organisms or even be applied to human biology one day? And what would the ecological consequences be if immortality became widespread in nature? Beyond the laboratory, the immortal jellyfish has entered the realm of speculation and myth. Some propose that its secret of eternal life might inspire new ways of thinking about aging, death, and regeneration. Others wonder if the jellyfish's regenerative abilities could be linked to the origins of life itself, reflecting ancient evolutionary pathways still preserved in its genes. Yet, caution remains essential. Much of the fascination arises from controlled observations, and how these processes play out in the wild is less clear. The immortal jellyfish's life cycle, while extraordinary, is just one thread in the vast tapestry of marine biology, a reminder of how much remains unknown beneath the waves. As we watch this translucent marvel pulse and drift, seemingly suspended between life and death, we are invited to ponder the mysteries of existence. Could the immortal jellyfish truly hold the key to eternal life? Or is it a unique curiosity, a natural wonder that hints at possibilities we have yet to fully comprehend? The ocean continues to harbor secrets that challenge our understanding of biology, mortality, and the very nature of life. The immortal jellyfish is but one enigmatic ambassador from the depths, reminding us that the boundary between science and mystery is often as fluid and shifting as the seas themselves. What other secrets lie hidden in the vast, unexplored oceans? The search for answers continues, silent, patient, and as deep as the waters that cradle these astonishing creatures. Beneath the crushing darkness of the ocean's abyss, where sunlight never penetrates and pressures reach unimaginable extremes, lie one of Earth's most enigmatic and alien landscapes, the black smokers. These hydrothermal vents, named for the thick black plumes of mineral-rich smoke they emit, rise like chimneys from the seafloor, creating underwater towers that seem to belong to another world entirely. In the midst of an environment so hostile to most life, black smokers harbor ecosystems thriving in complete darkness, powered not by sunlight but by geothermal energy seeping from the planet's molten core. Discovered only in the late 1970s along the Galapagos Rift, black smokers challenged long-held scientific assumptions about where and how life could exist. Unlike the photosynthetic life that dominates the surface world, these vents support unique communities fueled by chemosynthesis, bacteria that convert the vent's sulfur-rich chemicals into energy, forming the foundation of an entire food chain. Tube worms, giant clams, and myriad other creatures have adapted to survive in this extreme environment, thriving where it seemed impossible. The visual spectacle of black smokers is haunting. Towering columns of blackened rock, spewing superheated water exceeding 400 degrees Celsius, yet sustaining life in the surrounding cold, oxygen-rich ocean. The chemistry is equally extraordinary. Dissolved minerals precipitate out of the vent fluid, building chimneys of metal sulfides that can grow several meters high. These are not merely geological structures, but living, evolving ecosystems at the boundary between geology and biology. Yet, beyond their scientific marvel, black smokers raise profound questions. How did life first arise on Earth? Could these vents be the primordial cradles where the earliest forms of life emerged, harnessing chemical energy before the evolution of photosynthesis? The very conditions at black smokers mimic what we believe existed on the ancient Earth, fueling hypotheses that life itself may have started in these dark, mineral-rich environments. Moreover, black smokers spark tantalizing speculation about life beyond Earth. If life can thrive in such extreme, sunless conditions here, might similar hydrothermal systems on moons like Europa or Enceladus harbor life as well? The study of these alien vents is not only about understanding our own planet, but also about expanding the possibilities of life in the cosmos. Despite decades of research, many mysteries linger. The exact mechanisms allowing such rapid mineral precipitation and chimney formation remain under investigation. The intricate symbiosis between microbes and animals, how these relationships evolved, and how they sustain these ecosystems through geological upheavals still puzzle scientists. Could there be undiscovered organisms or biochemical processes at play? Furthermore, some deep-sea explorers report phenomena that defy easy explanation. Unusual vent structures, mysterious microbial mats with unknown properties, and unexplained chemical anomalies challenge our understanding of these environments. Are we glimpsing only the surface of a far more complex and dynamic system? The pressures, temperatures, and chemical gradients at black smokers push life to its limits, forcing adaptations that seem alien to our terrestrial experience. How do these creatures regulate their metabolism in such extremes? What secrets do their genomes hold about survival and resilience? As we descend deeper into this underwater realm, black smokers reveal a world where life redefines itself in darkness and heat. They invite us to reconsider what life means, how it persists, and where it might exist beyond our familiar horizon. The alien vents beneath our oceans whisper of ancient origins and cosmic possibilities. A reminder that the deep sea remains one of Earth's last frontiers, where every discovery leads to new questions. What other secrets are hidden within these towering chimneys? What truths might they reveal about life's enduring tenacity, or about worlds yet to be explored? The mystery endures, waiting patiently beneath the crushing weight of the ocean, in the black smoke rising from Earth's molten heart. Beneath the vast inky expanse of the deep ocean, where sunlight fails to reach and darkness reigns unchallenged, a subtle yet mesmerizing spectacle unfolds. It is the phenomenon of bioluminescence, a natural light show unlike any other on Earth. Flickering, glowing, and pulsing across the abyssal depths, bioluminescence illuminates the dark waters with eerie blues, greens, and occasional flashes of red, creating a world both alien and enchanting. But what drives this silent display? And what secrets does it hold in the depths where human eyes rarely wander? Bioluminescence, the production and emission of light by living organisms, is widespread in the deep sea, where as much as 90% of creatures possess this ability. From microscopic plankton to giant squid, countless species have evolved to generate their own light through complex chemical reactions within their bodies. This light serves many purposes: attracting prey, deterring predators, communicating with mates, or even camouflaging themselves against the faint glow from above. Yet, despite decades of research, the full extent of bioluminescence's role and the diversity of its mechanisms remain veiled in mystery. Imagine a dark, cold world where light is a rare commodity, yet life has not only adapted to the absence of the sun but has turned to self-generated light to survive and thrive. Strange creatures drift through this darkness, their bodies glowing with ethereal pulses, some emitting steady glows, others flashing in intricate patterns. The diversity is staggering. The anglerfish's glowing lure tempts unsuspecting prey, while the startled squid ejects a bioluminescent cloud to confuse predators. Some species communicate with precise light patterns, like an underwater Morse code, hinting at complex social behaviors far removed from surface dwellers. How did such remarkable adaptations evolve? What triggers these organisms to light up in such a vast and hostile environment? The chemistry of bioluminescence centers around molecules called luciferins and enzymes known as luciferases. Yet, nature has evolved dozens of variations on this basic theme. Different species have tailored their light production to fit their unique needs and environments, producing light at different wavelengths, intensities, and durations. This biochemical diversity points to a long evolutionary history, shaped by the pressures and peculiarities of the deep ocean. But questions remain. How do these creatures regulate their bioluminescence with such precision? Can they control it consciously, or is it a reflexive response to environmental cues? Some researchers propose that bioluminescence may even play a role in navigation or spatial awareness in the abyss, acting as a biological flashlight or beacon in the dark. Others speculate that bioluminescent signals could carry messages across vast distances, perhaps even across species, forming a hidden language yet to be deciphered. Intriguingly, bioluminescence also presents puzzles about life's resilience and creativity. How do biochemical pathways produce light so efficiently in such cold, high-pressure environments? What evolutionary pressures have led to such convergence across unrelated species? Could the study of bioluminescence lead to new technologies, inspired by nature's ability to generate light without heat or electricity? Even more tantalizing are rare reports of unusual or unexplained bioluminescent phenomena, strange flashes, glows, or patterns that don't match known species or behaviors. Some deep-sea explorers recount witnessing vast fields of light flickering across the ocean floor, or fleeting shapes pulsing in ways that defy explanation. Could these be unknown organisms, or even collective behaviors of multiple species? Or might they hint at phenomena still beyond our understanding? The study of bioluminescence is a journey into the heart of nature's ingenuity, a window into an underwater world that thrives in perpetual night. It challenges us to rethink the role of light in life's evolution and to appreciate the delicate balance of chemical, biological, and environmental factors shaping these luminous lives. As we watch this deep-sea light show, glowing quietly beneath the waves, we are reminded that even in the darkest corners of our planet, life finds a way to shine. What stories lie behind these glimmers? What undiscovered marvels await, shimmering just beyond our reach? The ocean's bioluminescent ballet continues, a silent dance in the dark, urging us to explore further, question deeper, and wonder at the mysteries still hidden beneath the surface. Far below the sunlit ocean surface, in the realm where darkness is eternal and pressures soar to crushing extremes, dwells a creature both enigmatic and haunting, the vampire squid. Unlike the sinister legends its name conjures, this elusive inhabitant of the deep is a marvel of adaptation, embodying mystery and survival in one of Earth's most forbidding environments. Cloaked in velvety midnight hues, with webbed arms lined by delicate spines that resemble a cloak or cape, the vampire squid seems as much a creature of fantasy as of biology. Scientifically known as Vampiroteuthis infernalis, which translates roughly to vampire squid from hell, this species inhabits depths ranging from 2,000 to 3,000 meters, a twilight zone so dim that even bioluminescent light struggles to penetrate. Here, temperatures hover just above freezing, and oxygen levels are astonishingly low, conditions inhospitable to most marine life. Yet the vampire squid not only endures but thrives, its physiology finely tuned to this extreme habitat. At first glance, the vampire squid appears to blur the lines between squid and octopus, possessing traits of both but belonging to its own unique order. Its large bulbous eyes, adapted to capture the faintest glimmers of light, dominate its head, providing a ghostly gaze into the abyss. Surrounding its mouth are 8 arms connected by a web of skin, which the animal can retract or extend like a cloak, a behavior both mesmerizing and mysterious. One of the vampire squid's most intriguing features is its bioluminescent capabilities. It produces light not to attract prey or mates, as many deep-sea creatures do, but seemingly as a defense mechanism, releasing glowing mucus clouds that can confuse or deter predators. This glow, eerie and fleeting, adds to the creature's otherworldly reputation. Yet, many questions remain. What evolutionary pressures sculpted such a unique strategy? How does bioluminescence function so effectively in such a sparse environment? The vampire squid's feeding habits further deepen the mystery. Unlike many of its cephalopod relatives, it does not hunt live prey aggressively. Instead, it feeds on marine snow, a slow drift of dead organic matter, fecal pellets, and other detritus descending from upper ocean layers. With filamentous sensory structures, it gathers this sparse nutrient supply, surviving in an ecosystem where food is scarce. This unusual diet has led scientists to reconsider the vampire squid's ecological role and evolutionary origins. Despite extensive study, much about the vampire squid's life cycle, reproductive behaviors, and population dynamics remains obscure. Its slow metabolism and delicate body challenge researchers who attempt to observe it in its natural habitat. Some speculate that its unique adaptations hint at a long evolutionary history, perhaps representing a lineage distinct from other cephalopods that diverged millions of years ago. Speculation extends beyond biology. Could the vampire squid's ancient traits be a living window into the deep ocean's evolutionary past? Does its enigmatic existence suggest a resilience to climate or environmental changes that elude other species? And might its mysterious behaviors harbor unknown biochemical or physiological mechanisms waiting to be discovered? Far beneath the waves, in the shadowy depths where sunlight struggles to reach, lives a creature whose very anatomy challenges our understanding of evolution and adaptation, the barreleye fish. This deep-sea dweller, known scientifically as Macropinna microstoma, is famed not only for its elusive nature, but for an astonishing feature that has captivated scientists and ocean enthusiasts alike: a transparent, dome-shaped head through which its eyes can be seen in all their eerie, upward-facing glory. Imagine descending into a world of perpetual gloom, where the faintest glimmers of light filter down from far above, and every shadow could conceal a predator or prey. In this dim environment, vision becomes a crucial lifeline. Yet, the barreleye fish has taken visual adaptation to a level that seems almost surreal. Its tubular eyes, capable of rotating independently within the transparent dome, allow it to scan the waters above and around with an almost panoramic perspective. Through this glassy dome, the barrel-like eyes appear as green, reflective orbs, designed to capture the most elusive traces of bioluminescence or silhouettes of drifting creatures. The transparency of the head was a discovery that sent ripples through the scientific community when first documented. Unlike any other known fish, the barreleye's cranial dome is completely see-through, revealing the delicate, soft tissues and the dark eyes inside. What evolutionary advantage does such a seemingly vulnerable design provide? Could it be a shield that protects the eyes from the stings and toxins of jellyfish, prey the fish is known to hunt? Or does the dome serve to channel light in ways we have yet to fully comprehend? While the barreleye's unique anatomy has been studied extensively since the early 2000s, much about its behavior and ecology remains enigmatic. Equipped with highly specialized eyes adapted to detect the faint glow of bioluminescent organisms, the fish seems perfectly tuned to a niche in the deep-sea food web. But what else might this see-through head conceal? Are there aspects of its physiology or sensory capabilities that remain beyond our current technological reach? Some scientists speculate that the Barreleye's transparent dome may provide insights into evolutionary strategies for survival in extreme environments. Could this anatomical feature represent an ancient adaptation, a holdover from a bygone era of deep-sea life? Or is it a marvel of recent evolutionary innovation, born from the pressures of life in the abyss? The Barreleye's very existence raises deeper questions about the mysteries lurking beneath the ocean's surface. How many other creatures with such baffling adaptations have yet to be discovered? What secrets lie in the ways these animals perceive their world, so alien to human senses, yet perfectly suited to the deep? Even more intriguing are sporadic reports from deep-sea submersibles and remote-operated vehicles of Barreleye fish exhibiting behaviors that puzzle researchers. Slow, deliberate movements, sudden shifts in eye orientation, and interactions with bioluminescent prey that hint at complex sensory processing. Could these be signs of intelligence or awareness that we barely understand? As we peer into the transparent head of the Barreleye fish, we are reminded that the deep ocean is not just a dark abyss, but a realm of extraordinary adaptations and hidden wonders. The see-through dome serves as a metaphor for the fragile veil of knowledge we have about life in the depths, partially revealed, yet still cloaked in mystery. What other secrets might the Barreleye's clear head conceal? How much more is there to learn about the unseen world beneath the waves, where evolution paints in transparent brushstrokes and light itself becomes a precious commodity? The exploration continues, with the Barreleye fish inviting us to look deeper, through the glass and into the unknown. Alternatively, could Julia be biological in origin? The ocean harbors countless creatures, many still undiscovered, each with its own communication methods. Might Julia represent the call of a deep-sea species unknown to science, communicating in frequencies beyond human hearing ranges? If so, what kind of creature produces such a signal, and what purpose does it serve? There are also more speculative theories. Some have suggested that Julia could be an artifact of human activity, sonar signals, underwater equipment interference, or secret military communications inadvertently recorded in these vast soundscapes. However, no conclusive evidence has supported these ideas, and the pattern's consistency challenges explanations rooted solely in human technology. What makes Julia especially perplexing is the silence that surrounds it. Despite advanced mapping and acoustic monitoring technologies, attempts to localize the source have failed. It drifts like a phantom through the oceanic soundscape, its origin point hidden in a labyrinth of water and pressure. This lingering enigma invites reflection on the ocean's vastness and the limits of human understanding. The depths remain one of the least explored frontiers on Earth, a place where nature's rhythms play out beyond our senses and comprehension. Julia serves as a reminder that beneath the waves, mysteries endure, echoes of a world both familiar and profoundly alien. As we listen to Julia's strange pulses, we wonder, what truths might lie hidden in the deep, waiting for discovery? How many voices of the ocean remain unheard? And what stories do these unexplained sounds tell about the life and geology of our planet's last great frontier? The ocean song continues, and with it, the call to explore further into the unknown. Far beneath the shimmering surface, where sunlight is but a distant memory and the ocean plunges into endless twilight, there lurks a creature that seems to have swum through time itself, the frilled shark. With its elongated body, primitive features, and serpentine grace, this deep-sea enigma offers a glimpse into the prehistoric seas, earning it the evocative title of a living fossil. To witness the frilled shark is to encounter a relic of Earth's ancient past, preserved in the abyssal depths that few have seen and fewer still have studied. Measuring up to 2 meters long, the frilled shark's sinuous body is covered in dark, smooth skin, punctuated by 6 pairs of frilly gill slits, hence its name. Its mouth, filled with rows of needle-sharp, trident-shaped teeth, appears both terrifying and fascinating, designed to trap slippery prey in the cold, crushing darkness. This creature's morphology, largely unchanged for millions of years, suggests a lineage dating back to the late Cretaceous period, a time when dinosaurs still roamed the land. Found at depths ranging from 200 to over 1,500 meters, the frilled shark occupies a mysterious niche. It moves with a slow, undulating motion reminiscent of an eel, navigating the murky waters where pressure mounts and temperatures plummet. Sightings are rare, often accidental, from deep-sea submersibles or fishing nets, which only adds to its aura of mystery. Scientifically, the frilled shark is fascinating not only because of its ancient lineage, but also due to its elusive biology. Researchers know little about its reproductive habits, growth rates, or lifespan, but some evidence suggests that it matures extremely slowly and may live for decades. How does a species with such a low reproductive rate survive in such a challenging environment? What adaptations allow it to endure where others cannot? Its ancient features prompt further questions. Why has the frilled shark remained so unchanged, seemingly untouched by the evolutionary pressures that transformed other species? Is it a case of evolutionary stasis, where the deep sea's stable environment favors conservation over change? Or could the frilled shark's physiology harbor secrets about vertebrate evolution, insights that have yet to be fully explored? Some fringe theories speculate that the frilled shark may even have undiscovered behaviors or biological traits, perhaps related to its sensory systems or biochemistry, that challenge current scientific understanding. Could it possess unique adaptations to detect prey or avoid predators in the perpetual darkness? Might it have chemical properties or genetic traits with implications far beyond marine biology? The frilled shark's occasional appearances in the press often spark imaginations, fueled by its prehistoric appearance and the haunting images captured by deep-sea cameras. But beyond these superficial fascinations lies a deeper mystery, one of survival, adaptation, and the enduring resilience of life in Earth's most remote places. As we peer into the abyss where the frilled shark glides silently, we confront the profound unknowns of the deep sea. What other ancient creatures lie hidden in the shadows, waiting to be discovered? How much more can this living fossil teach us about the origins and persistence of life itself? The frilled shark, a ghost from the past, invites us to ponder the ocean's depths, not only as a frontier of mystery but as a repository of nature's oldest stories, still unfolding in the silence beneath the waves. As we explore this spectral inhabitant of the abyss, the vampire squid serves as a potent reminder of the ocean's vast unknowns, a creature caught between myth and science, light and darkness. Its ghostly presence invites reflection on the nature of adaptation, survival, and the hidden stories that lie in the ocean's deepest shadows. What other secrets does the vampire squid conceal in its silent domain? How much more is left to uncover in the depths where even light is a rare visitor? The journey into the deep continues, with the vampire squid as both guide and enigma, urging us to delve further into the mysteries that science has yet to explain. Far beneath the ocean's restless surface, amid the crushing darkness and icy silence, lies a mystery that continues to baffle scientists and echo through the depths. The enigmatic sound known as Julia. Detected by underwater listening devices, this peculiar signal has haunted the maritime research community for decades. A ghostly signature recorded from the abyss, yet whose origin remains frustratingly elusive. The story of Julia begins with the advent of sophisticated hydrophone technology, designed to eavesdrop on the ocean's hidden conversations. These underwater microphones pick up a symphony of sounds, from the songs of whales to the grinding of tectonic plates. But amid this acoustic tapestry, Julia emerged as something entirely different. First recorded in the late 20th century, the sound was a strange, rhythmic pulse that did not match any known marine species or geological phenomenon. Julia's signature is hauntingly distinct, a pattern of low-frequency clicks and pulses that seem almost deliberate, structured, yet alien. Unlike the complex songs of dolphins or the repetitive calls of certain whales, Julia's acoustic pattern defies easy categorization. Its persistence over time and space only deepened the mystery, prompting scientists to scour data from different oceans, trying to trace its source. Could Julia be a product of the ocean itself? A geological process or an underwater volcanic event yet to be fully understood? Some geophysicists speculate that the sound might originate from shifting tectonic plates or deep-sea vents, where minerals interact under intense pressure. Yet, the acoustic patterns don't fully align with any known geological activity. Alternatively, could Julia be biological in origin? The ocean harbors countless creatures, many still undiscovered, each with its own communication methods. Might Julia represent the call of a deep-sea species unknown to science, communicating in frequencies beyond human hearing ranges? If so, what kind of creature produces such a signal, and what purpose does it serve? There are also more speculative theories. Some have suggested that Julia could be an artifact of human activity, sonar signals, underwater equipment interference, or secret military communications inadvertently recorded in these vast soundscapes. However, no conclusive evidence has supported these ideas, and the pattern's consistency challenges explanations rooted solely in human technology. What makes Julia especially perplexing is the silence that surrounds it. Despite advanced mapping and acoustic monitoring technologies, attempts to localize the source have failed. It drifts like a phantom through the oceanic soundscape, its origin point hidden in a labyrinth of water and pressure. This lingering enigma invites reflection on the ocean's vastness and the limits of human understanding. The depths remain one of the least explored frontiers on Earth, a place where nature's rhythms play out beyond our senses and comprehension. Julia serves as a reminder that beneath the waves, mysteries endure, echoes of a world both familiar and profoundly alien. As we listen to Julia's strange pulses, we wonder, what truths might lie hidden in the deep, waiting for discovery? How many voices of the ocean remain unheard? And what stories do these unexplained sounds tell about the life and geology of our planet's last great frontier? The ocean's song continues, and with it, the call to explore further into the unknown. Beneath the vast, endless expanse of the Pacific Ocean lies a sound so persistent, so mysterious, that it has captured the curiosity of oceanographers and acousticians for decades. Known simply as the UPSWEEP, this deep, haunting hum reverberates through the water like a slow, celestial chant, one that defies easy explanation and continues to puzzle scientists around the globe. The story of the UPSWEEP begins in the early 1990s, when underwater hydrophones, sensitive microphones designed to capture the ocean's sonic landscape, first detected this curious acoustic signal. Unlike the sharp clicks and whistles typical of marine mammals or the rumbling groans of underwater earthquakes, the UPSWEEP consists of a series of long, rising tones, resembling a slow, musical scale climbing upwards. The sound stretches across hundreds of miles, echoing through the deep, cold waters with a regularity that is both mesmerizing and perplexing. Its source remains elusive, buried in the ocean's deepest trenches and ridges. Efforts to pinpoint where exactly the upsweep originates have been inconclusive, despite extensive monitoring and advanced sonar mapping. The tones shift in frequency and intensity, sometimes growing louder, then fading into silence, only to return again, like a cryptic message from the abyss. Scientists have proposed a variety of explanations. Some suggest that the upsweep is a natural phenomenon, perhaps linked to underwater volcanic activity. Hydrothermal vents, known to release heated, mineral-rich water from beneath the Earth's crust, could generate acoustic signals as the pressure and temperature fluctuate. Yet, the precise pattern and consistency of the upsweep do not entirely match known volcanic sounds. Others theorize that the sound could be related to the movement of tectonic plates. The ocean floor is a dynamic landscape, with plates constantly shifting and grinding against one another. Could the upsweep be a sonic signature of these slow geological processes, a distant tremor or a warning sign of future seismic events? More speculative ideas have emerged as well. Some researchers wonder if the sound might be biological, produced by a yet undiscovered species of deep-sea creature communicating in a frequency range humans can barely perceive. The ocean, after all, is home to countless mysteries, and its inhabitants have evolved extraordinary adaptations to the darkness and pressure of the deep. Others consider the possibility that the upsweep might even be related to human activities, such as distant sonar signals or underwater industrial noise. But the ocean is vast, and the pattern of the upsweep appears too natural, too complex, to be dismissed as merely anthropogenic interference. What makes the upsweep especially compelling is its uncanny persistence. For decades, this sound has echoed beneath the waves, indifferent to the passing of time and humanity's ever-growing knowledge of the deep. It challenges our understanding of the ocean as a living, breathing system, a system that speaks in tones we have yet to decode. Could the upsweep be a kind of cosmic music composed by the Earth itself, or is it a secret language from the depths, one we have only just begun to hear? The ocean guards its mysteries jealously, and the upsweep stands as a sonic testament to what remains undiscovered. As we listen to this slow, rising hum beneath the waves, we are reminded that the ocean is more than a vast body of water. It is a realm of sound, shadow, and wonder. The upsweep invites us to listen more closely, to question more deeply, and to accept that some secrets of the sea may forever elude our grasp. What other voices lie beneath the surface, waiting to be heard? And what stories do they tell about the unseen rhythms of our planet? The ocean's mysteries endure, and so does our quest to understand them. Beneath the roaring eruptions of hydrothermal vents, those underwater geysers that spew superheated mineral-rich water from the Earth's crust, an otherworldly spectacle unfolds. Clusters of translucent gelatinous blobs drift silently amidst the scalding plumes, their shimmering forms pulsing gently in the dark abyss. They seem almost alien, like enigmatic life forms suspended between fluid and flesh, defying simple explanation. Are these strange entities alive? Or are they mere mineral formations shaped by the ocean's extremes? The discovery of these gelatinous blobs began with deep-sea exploration missions using remotely operated vehicles, ROVs, equipped with high-definition cameras. As scientists delved into the black smoker's realm, where temperatures can exceed 400 degrees Celsius and pressures soar to crushing levels, these blobs emerged as haunting fixtures around the vents, clinging to rocks or drifting slowly with the currents. Visually, they resemble large translucent spheres or ovals, sometimes with faint internal structures that suggest complexity. Their slow, rhythmic pulsations give the impression of subtle movement, hinting at something more than simple inanimate matter. Yet, no definitive biological characteristics such as defined organs, muscles, or skeletons have been confirmed, leaving their nature ambiguous. Could these gelatinous blobs be a previously unknown form of life, adapted to the vent environment's extreme conditions? Life at hydrothermal vents is extraordinary. Entire ecosystems thrive without sunlight, relying instead on chemosynthesis, microbes converting chemicals from vent fluids into energy. Among these unique organisms are giant tube worms, strange crustaceans, and heat-tolerant bacteria. Could these blobs represent another marvel of evolution? A simple but resilient life form that blurs the line between biology and geology? Some marine biologists hypothesize that the blobs could be colonies of bacteria or microbial mats encased in gelatinous substances, offering protection in this volatile habitat. Alternatively, they might be aggregates of organic and inorganic materials formed through complex chemical reactions driven by vent emissions. These living rocks might slowly accumulate matter, giving them an eerie semblance of life. Further complicating the mystery, these gelatinous spheres sometimes appear to respond to stimuli, contracting or altering shape when disturbed by nearby ROVs, though observations remain sparse and inconclusive. Do they possess a primitive form of responsiveness, or are these movements purely physical reactions to external forces? Beyond biology, some geochemists suggest these blobs might be mineral precipitates, silicates or sulfides, that crystallize in the unique vent chemistry. Under extreme pressure and heat, minerals can adopt unusual, organic-like shapes. This raises profound questions about the boundary between living and non-living matter, especially in such a hostile environment. Speculative theories have also emerged. Could these blobs represent an early stage of life's origin, akin to protocells or primordial life forms that predate complex organisms? The deep ocean has long been considered a cradle of life on Earth. If these gelatinous forms are indeed alive, might they offer clues about how life began under such extreme conditions billions of years ago? Others ponder whether these blobs could be sentient or possess some unknown intelligence, given their apparent ability to move and persist amid the harshest conditions on the planet. While no evidence supports such claims, the very mystery invites us to consider the vast unknowns lurking at the ocean floor. The enigma of these gelatinous blobs challenges the boundaries of our knowledge, compelling scientists to reconsider what defines life itself. Are they living organisms, complex mineral structures, or something in between, a hybrid of biology and geology born from the ocean's elemental forces? As we observe these ghostly spheres drifting near hydrothermal vents, questions abound. How do they survive the toxic, boiling waters? What role do they play in the vent ecosystem? And what secrets do they hold about life's resilience and adaptability? The ocean's depths continue to conceal wonders that stretch the imagination and test the limits of science. These gelatinous blobs remain an open question, inviting us to explore deeper, look closer, and embrace the mystery of a world that refuses to be fully understood. What other secrets do the dark, scalding waters hide? And what new forms of life await discovery, shimmering just beyond our reach? The journey into the unknown continues. Far beyond the reach of human eyes, the vast expanse of the world's oceans occasionally unveils a spectacle, both haunting and beautiful, a phenomenon known as the Milky Sea. From the quiet solitude of space, satellites have captured images of these glowing waters, vast swathes of the ocean mysteriously illuminated, as if lit from within by a ghostly, milky light. This rare event, flickering like a spectral glow across the night sea, has long fascinated sailors and scientists alike, sparking questions that remain unanswered to this day. The Milky Sea phenomenon was first documented by sailors centuries ago, their logs recounting nights where the sea appeared to glow eerily, extending over tens of thousands of square kilometers. Yet, it was only with the advent of modern satellite technology that researchers could confirm its true scale and attempt to unravel its nature. These glowing patches are not the result of moonlight or bioluminescence from individual creatures, but are thought to be caused by the combined light emitted by enormous colonies of bioluminescent bacteria. The bacteria, likely Vibrio species, produce light through a chemical reaction that involves the enzyme luciferase, emitting a soft, steady glow visible even from space. But why and how these bacteria assemble into such vast, uniform expanses remains a puzzle. Conditions must align perfectly – temperature, nutrients, ocean currents – to create this breathtaking spectacle. This confluence of factors makes each Milky Sea event rare and transient, vanishing as suddenly as it appears. Scientists have gathered evidence from both satellites and ships that have sailed through these glowing waters, reporting an uncanny stillness and an otherworldly luminescence that bathes the ocean in a pale blue-white light. Observers have noted that the glow remains consistent even when the water is disturbed, a property unusual for most bioluminescent phenomena, which tend to flicker or pulse with movement. Could this steadiness hint at a unique biological or chemical mechanism at work? Beyond the biological explanations, some researchers have pondered the possibility of more complex interactions. Could the glowing colonies represent a vast, cooperative ecosystem, communicating or interacting in ways we do not yet understand? Might these bacteria be responding to environmental cues on a planetary scale, their luminescence serving functions beyond mere survival, perhaps as a signal or a form of oceanic communication? Speculative theories extend even further. Some have suggested that the Milky Sea might be linked to unknown oceanic processes, such as chemical emissions from hydrothermal vents or undersea volcanic activity, which could stimulate bacterial growth or even influence the glow. Others wonder if these events are connected to changes in ocean currents or global climate patterns, serving as subtle indicators of shifting environmental dynamics. The rarity and mystery of the Milky Sea continue to challenge scientists. How often do these glowing waters appear? What exactly triggers their formation and disappearance? And what role do they play in the broader ocean ecosystem? Each question deepens the enigma, reminding us how much remains undiscovered beneath the waves. As we contemplate this celestial glow, visible from the heavens yet born of microscopic life, we are humbled by the ocean's complexity and the delicate balance sustaining it. The Milky Sea stands as a luminous reminder that the sea still holds secrets that defy explanation, beckoning us to explore further, to look deeper, and to listen more closely to the whispers of the deep. What other wonders lie hidden beneath the surface, waiting to reveal themselves only in the quiet darkness of night? The glow fades, but the mystery lingers on. Flowing from the glowing expanse of the Milky Sea, we now descend even deeper into the enigmatic realm of the ocean floor, where vast circular patterns emerge from the dark, silent depths, defying easy explanation. These are the mysterious underwater circles, perfectly formed rings etched into the seabed that spark questions about the forces shaping our planet's hidden landscapes. Are these curious formations simply the product of natural processes, or could they be evidence of something more deliberate, perhaps even intelligence? First discovered through deep-sea exploration and sonar mapping, these enigmatic circles range from a few meters to several tens of meters in diameter. Their symmetry and size immediately draw the eye, evoking wonder and skepticism in equal measure. what could carve such precise shapes into the ocean floor, thousands of meters beneath the waves, where sunlight never reaches and human hands cannot easily intervene? Scientists initially proposed several natural causes. Some suggest that these circles are created by unusual sedimentary patterns or by the activity of ocean currents interacting with the seafloor's unique topography. Others attribute them to geological phenomena such as methane seepage or gas hydrate formations, which might cause the seafloor to collapse or shift in ways that create circular impressions. Yet, none of these explanations fully account for the remarkable regularity and spacing observed among certain clusters of circles. Adding to the intrigue, some circles exhibit subtle ridges, raised edges, or even internal spirals, features that challenge purely geological interpretations. Could marine life be involved? The behavior of certain deep-sea creatures, like the large, elusive pufferfish, which is known to sculpt intricate circular nests in shallower waters, invites speculation about whether unknown or undiscovered species might be responsible for the ocean floor's giant counterparts. Could these mysterious circles be the underwater equivalent of artistic expression or mating displays on a monumental scale? From a more speculative perspective, some researchers have entertained the idea that these formations might be signs of intelligence, whether from as yet undiscovered deep-sea creatures or other phenomena. The possibility that these circles are messages, nests, or territorial markers challenges our understanding of life's complexity in the ocean's abyss. If intelligence can manifest here, where sunlight fails to penetrate and pressure crushes most known forms of life, what might that tell us about the adaptability and diversity of marine life? Remote-operated vehicles, ROVs, and underwater drones have captured images of these circles, revealing their sheer scale and symmetry. Yet, investigations are hindered by the ocean's vastness and the logistical challenges of deep-sea exploration. Each dive uncovers more circles but fewer answers, deepening the mystery. Are we looking at an ancient natural phenomenon that has persisted for millennia, or something more recent, alive and evolving beneath the waves? The circles have also stirred the imagination beyond the realm of science. Some propose they could be remnants of ancient civilizations, or artifacts left by long-lost peoples, preserved in the ocean's depths. Others speculate about extraterrestrial involvement, drawing on the circle's enigmatic appearance and the ocean's position as Earth's final frontier. While such ideas remain speculative and outside mainstream science, their persistence highlights our fascination with the unknown and the limits of human knowledge. What if the ocean floor itself is a vast canvas, painted by forces both natural and intelligent, visible only when we learn to look closely enough? Could these formations represent a form of communication, one written not in words but in geometry and scale, waiting for us to decipher? As we continue to map and explore, these underwater circles remind us that even the seemingly empty abyss teems with secrets. The interplay between nature and mystery invites us to question what we accept as possible and to remain open to discoveries that may forever change our understanding of life beneath the waves. What stories lie hidden in these perfect rings? Stories the ocean has kept silent for centuries. The ocean whispers on, its secrets waiting for those who dare to listen. Beneath the tranquil waters off the coast of Yonaguni, a small island in southern Japan, lies a submerged wonder that has ignited debate for decades. A massive underwater structure with angular terraces, sharp edges, and what appear to be steps and platforms carved with precision. Known as the Yonaguni Monument, this enigmatic formation rises from the ocean floor at depths reaching up to 25 meters, its imposing presence visible through clear, jade-green waters. To some, It is a breathtaking natural marvel, sculpted by the forces of time and tide. To others, it is the long-lost remnant of an ancient civilization, swallowed by rising seas thousands of years ago. The discovery of the Yonaguni monument in 1986 by local diver Kihachiro Aratake sparked immediate fascination and controversy. At first glance, the structure's geometric shapes and seemingly architectural design suggest human craftsmanship. Massive stone terraces resemble steps, while flat surfaces and sharp corners defy the smooth curves typically shaped by erosion and underwater currents. Such features invite questions. Could this be evidence of a prehistoric city, hidden beneath the waves and lost to memory? Or are these formations the product of nature's uncanny ability to imitate human artistry? Geologists often point to the region's unique geology to argue for a natural origin. The monument is primarily composed of sandstone and mudstone, rock types prone to fracturing along straight lines, which can create angular shapes. Tectonic activity, combined with waves and currents over millennia, could plausibly have carved the terraces and ledges. The site's location near fault lines and earthquake zones adds weight to the theory that seismic shifts fractured the bedrock into what we see today. Indeed, natural formations can sometimes surprise us with their precision. However, the precision and scale of some of the features challenge this explanation. The presence of what appears to be a carved pillar, large, flat plazas, and intricate terraces raise the possibility of intentional shaping by human hands. Supporters of the man-made theory point to ancient legends and oral histories in the region, hinting at civilizations lost beneath rising seas after the last ice age, when global sea levels rose significantly. Could these underwater terraces have once been part of a sprawling city, now submerged by climate shifts? The debate deepens when divers report finding artifacts nearby, stone tools and pottery shards, although many remain unverified or inconclusive. Some researchers speculate that even if the monument itself is natural, it may have been modified or used by ancient peoples, blending human influence with geological formations. This idea presents a middle ground that complicates simplistic explanations. Yet, even the notion of a lost civilization challenges established timelines of human development. If Yonaguni is indeed man-made, it would predate known ancient architecture in the region by thousands of years, forcing us to reconsider the capabilities and spread of prehistoric cultures. Could there have been civilizations advanced enough to build such structures before recorded history? And if so, what else might have been lost beneath rising waters? More fringe theories add layers of intrigue. Some suggest the monument might be evidence of an unknown civilization connected to myths like Mu or Lemuria, lost continents said to have vanished in the ocean. Others speculate about extraterrestrial involvement, or that the monument serves as a kind of underwater monument or ritual site whose true purpose remains beyond our understanding. Modern technology has allowed researchers to map the site in unprecedented detail using sonar, 3D imaging, and underwater drones. Yet, the clarity these tools provide only raises more questions. Precise measurements reveal patterns and alignments that appear deliberate, but natural processes are still plausible explanations. What forces shaped these forms? How much is nature, and how much is human hands? The Yonaguni monument invites us into the heart of one of the ocean's greatest mysteries. It challenges our understanding of history, geology, and the ocean itself. Is it a silent testament to an ancient world erased by time and water, or a remarkable illusion crafted by the Earth's relentless forces? As we gaze through the shimmering waves at these submerged terraces, we are reminded that beneath the surface lies a world where fact and mystery blur. The truth remains elusive, waiting for discovery by those willing to dive deeper, into the ocean's depths and into history's shadows. What secrets does Yonaguni still hold? What stories are etched into those stone steps, silent yet speaking through the ages? The ocean keeps its secrets well, and this monument remains a tantalizing puzzle beneath the waves. Beneath the murky depths of the Baltic Sea, resting on the cold, dark seafloor at approximately 90 meters below the surface, lies a perplexing formation that has captivated scientists, explorers, and conspiracy theorists alike: the Baltic Sea anomaly. Discovered in 2011 by a team of Swedish divers from OceanX, this strange, disc-shaped object measures nearly 60 meters in diameter and features sharp edges, flat surfaces, and a structure that seems unnervingly artificial. Its very presence challenges our understanding of what lies beneath the waves in one of the world's most thoroughly charted seas. At first glance, the anomaly appears to resemble a colossal, sunken UFO, or a piece of ancient technology lost to time. Photographs and sonar images reveal what look like staircases, ramps, and geometric patterns, details not commonly found in natural rock formations. Its odd shape, resembling a large mushroom or a circular spaceship, has sparked widespread speculation and imagination. But what is it really? Scientific teams quickly approach the anomaly with caution, deploying underwater robots and sonar scans to capture detailed images and samples. Initial analysis suggests that the formation is composed primarily of rock, perhaps glacial deposits, or an unusual geological formation caused by natural processes. Some experts propose that the object is a glacial erratic, an oddly shaped boulder transported and deposited by retreating glaciers at the end of the last ice age. Its smooth rounded contours and apparent symmetry could be explained by erosion and sedimentation. Yet, the Baltic Sea anomaly resists easy classification. Its sharp, angular features and the apparent steps or terraces defy many known natural processes. The surrounding seabed shows no clear signs of volcanic activity or other geological phenomena typically responsible for such formations. Some scientists suggest the possibility of a prehistoric human artifact, perhaps an ancient structure submerged by rising sea levels thousands of years ago. Could it be the remnants of a lost civilization, forgotten beneath layers of sediment and water? This theory, while captivating, faces significant challenges. The object's depth and the Baltic Sea's geological history make it unlikely to be a man-made structure from known ancient cultures. There is also no conclusive evidence of artifacts, tools, or human remains associated with the site. Yet the mystery persists. Why does this formation resemble an engineered object more than a natural one? Fringe theories abound, fueled by the object's uncanny shape and the eerie silence surrounding it. Some propose extraterrestrial origins, a UFO crash site frozen in time beneath the sea. Others suggest it could be an artifact from an ancient advanced civilization, like Atlantis, lost to the rising oceans after the last ice age. While lacking solid evidence, these ideas speak to a deeper human desire to uncover unknown histories and extraterrestrial secrets. The Baltic Sea itself adds layers of mystery to this puzzle. Its cold, low-salinity waters slow decay and preserve organic materials better than most oceans. This environment makes it a unique underwater archive, where remnants of the past might linger longer than usual. Might the anomaly be a preserved relic from a forgotten age, awaiting deeper exploration and technological breakthroughs to reveal its true nature? Explorations have been limited by the Baltic Sea's challenging conditions. Poor visibility, cold temperatures, and treacherous currents complicate dives. As technology improves, further investigation may shed more light on this enigma. Yet, each new image or sonar scan seems only to deepen the mystery, revealing more complex shapes and surfaces that defy simple explanation. The Baltic Sea anomaly reminds us that even in places we think we know well, the ocean can harbor secrets that challenge our understanding of history, geology, and possibly even extraterrestrial life. It stands at the intersection of science and speculation, inviting us to question what lies beneath the surface and what stories remain untold. Is it a natural formation sculpted by ice and time? A sunken relic of a lost human world? Or something beyond our current grasp? An artifact waiting patiently in the dark, silent depths? The answers remain elusive, and the sea keeps its secrets close, whispering only to those willing to listen and explore. What truths does the Baltic Sea anomaly conceal beneath its cold, dark shroud? The mystery endures, beckoning the curious to dive deeper into the unknown. From the shifting dunes of desert landscapes to the silent depths of the ocean floor, the phenomenon of singing sands, long observed on land, has found an enigmatic counterpart beneath the waves. Hidden in the twilight zones of the deep sea, vast underwater sand dunes produce low, haunting acoustic signals that ripple through the water, creating a mysterious underwater hum. Scientists are only beginning to understand. These singing sand dunes beneath the ocean surface represent an acoustic mystery that challenges our understanding of marine geology and sound propagation. On land, singing sand dunes have long fascinated explorers and scientists alike. When dry sand grains of particular sizes slide against one another, they emit a sustained, eerie sound, like a distant flute or the soft moan of the wind. The exact mechanics depend on grain size, shape, moisture, and the dune's angle. Yet the mystery has largely been unraveled. But underwater, where grains settle and move differently under pressure and in the dark, the story is far less clear. Researchers deploying hydrophones and sonar systems in deep-sea regions such as the North Atlantic and off the coasts of California have detected unusual, sustained, low-frequency sounds emanating from underwater sediment fields. These sounds resemble the tonal quality of terrestrial singing sands, but stretched into deeper, more resonant waves that travel vast distances through the ocean's complex sound channels. What processes beneath the surface create these sounds? Are they the product of shifting sediments, underwater landslides, or the movement of strange biological communities interacting with the seafloor? The prevailing scientific explanation points to the movement of sand grains along submarine dunes caused by strong ocean currents. As these grains rub and collide, they generate vibrations that propagate as sound waves, sometimes audible for miles under the right conditions. This phenomenon, while partially understood, raises questions about the scale and intensity of these underwater acoustics, especially since the ocean is filled with myriad other sounds: whale songs, seismic activity, and man-made noise. Yet, these particular signals stand out for their persistence and tone. Moreover, unlike dry sand on land, underwater sands are saturated and experience pressures thousands of times greater, affecting how sound is produced and transmitted. This has led some scientists to hypothesize that the composition and arrangement of grains under pressure might be forming natural resonators or amplifiers, enhancing the acoustic signature in ways we do not yet fully grasp. Could unique mineral compositions or biological activity within these sands play a role in creating these enigmatic sounds? Beyond geology, intriguing connections have been made to the behavior of marine life. Some deep-sea creatures rely on acoustic signals for communication and navigation in the dark, vast ocean. Is it possible that the singing sands are a byproduct of biological interactions, microbial mats or burrowing animals disturbing sediment layers, inadvertently producing rhythmic sounds? Or might some species have adapted to exploit or even enhance these natural acoustic phenomena? Speculative theories take the mystery even further. Could these underwater acoustic signals be interpreted as natural music of the ocean, a phenomenon arising from the interplay of Earth's physical and biological systems in ways still hidden from human understanding? Or do these sounds carry messages or cues encoded within the seafloor, perhaps as ancient geophysical signatures preserved in sediment movements, waiting to be decoded? Some researchers ponder whether these acoustic signals might also influence broader oceanic processes, affecting sediment transport, ecosystem dynamics, or even seismic activity. Could the underwater singing sands be part of an intricate natural orchestra, signaling changes in underwater landscapes or warning of geological shifts beneath the seafloor? The possibility that these sounds serve as precursors or indicators of underwater earthquakes or landslides has yet to be thoroughly explored. Despite advances in oceanographic technology and acoustic monitoring, much about the singing sands remains elusive. Their elusive nature resists easy categorization, part geological, part acoustic, and perhaps part biological. Observing these phenomena directly is hampered by the ocean's inaccessibility, and even the most sensitive instruments can capture only fragments of the complex symphony playing beneath the waves. As we listen through hydrophones suspended in the deep, we are reminded that the ocean is not silent. It sings, hums, and whispers its stories in frequencies we are only beginning to hear. What secrets might these underwater melodies hold? How much do we still overlook in the acoustic tapestry of the deep? The singing sands beneath the sea invite us to question the boundaries of science and imagination alike. Their song continues, timeless and unresolved, a natural mystery beneath the waves, urging us to dive deeper, to listen closer, and to wonder what hidden truths resonate from the ocean floor. From the haunting melodies of the singing sands, our journey now takes us to the very edge of the known world, the Mariana Trench, the deepest and most enigmatic abyss on our planet. Nestled in the western Pacific Ocean, this immense chasm plunges nearly 11 kilometers beneath the waves, a place where sunlight vanishes, pressures soar to crushing extremes, and temperatures hover just above freezing. It is here, at the Challenger Deep, the trench's deepest point, that mystery truly reigns, beckoning explorers and scientists alike to question what lies beyond the limits of human reach. The Mariana Trench has long fascinated researchers, divers, and dreamers. Sonar maps reveal a landscape of jagged peaks and vast trenches, shaped by tectonic forces over millions of years. The pressure here exceeds 1,000 times that at sea level, crushing metal and machinery alike, while the cold, pitch-black waters create an environment almost utterly alien to surface life. Yet, life endures. Strange, hardy creatures, many still undiscovered, adapt to this crushing darkness, challenging our understanding of biology and resilience. Over the past decades, manned and robotic missions have probed this underwater abyss. From the pioneering dives of Jacques Piccard and Don Walsh in the 1960s to James Cameron's solo descent in 2012, these voyages have captured fleeting glimpses of the trench's eerie, otherworldly ecosystem. Yet, despite these advances, the trench's greatest secrets remain out of reach, shielded by its inaccessibility and the limits of current technology. What exactly lies at the bottom? Science has identified creatures adapted to extreme pressure: amphipods, sea cucumbers, and unique microorganisms thriving in conditions once thought impossible. But what else might be concealed in the darkness? Are there unknown species, alien to our current understanding? Could geological anomalies or even traces of ancient life forms exist in this remote deep? Theories abound. Some suggest that the trench's vast depth may harbor ecosystems unlike any found elsewhere. isolated evolutionary pockets with creatures exhibiting extraordinary adaptations. Others speculate on the presence of unknown mineral deposits, rare earth elements, or even hydrothermal activity that defies current models. Could there be submersed geological formations that challenge established plate tectonic theories? The Mariana Trench also invites questions beyond biology and geology. It has become a subject of fringe speculation, from submerged cities to extraterrestrial artifacts hidden in its crushing depths. While such ideas lack concrete evidence, they underscore our fascination with the unknown and the limits of exploration. What if the trench acts as a natural archive, preserving ancient organic materials or clues to Earth's early history locked beneath layers of sediment? Could it even hold information about life's origins, given the extremophile organisms discovered near hydrothermal vents nearby? Yet, the deeper we delve, the more the trench reveals its impenetrable nature. The crushing pressures, near freezing temperatures, and utter darkness create formidable barriers. Even our most advanced technology can only skim the surface of this abyssal mystery. Each expedition uncovers new wonders, but also new questions. As we consider the Mariana Trench's deepest point, we are reminded of the ocean's vastness and the limits of human knowledge. The trench remains a symbol of mystery and discovery, a place where science meets wonder and the unknown beckons. What truths linger beneath those crushing depths? What creatures, structures, or phenomena await discovery in this final frontier? The Mariana Trench holds its secrets close, whispering to those who dare to listen and explore. The journey into the deep continues, with every descent offering a new chapter in our unfolding story of Earth's greatest mysteries. From the shadowed depths of the ocean's most extreme environments, our journey now drifts to an astonishing and little-known phenomenon: underwater brine pools, lakes within the ocean itself. These striking, salt-saturated bodies of water lie trapped on the seafloor, their surfaces sharply defined, shimmering like liquid mirrors amid the cold, dark ocean. At first glance, they appear as pools of ink or mysterious black holes, distinct and separate from the surrounding seawater. But these are not simple pockets of salt water. They are extreme, alien-like ecosystems that challenge everything we think we know about marine environments. Brine pools form where high concentrations of salt, often from salt deposits beneath the ocean floor, mix with seawater to create dense, viscous liquids far heavier than normal seawater. The result is a striking boundary where the pool's thick, salty water rests beneath lighter ocean water, forming a stable, persistent underwater lake. The surface tension between the two is so distinct that marine creatures can sometimes be seen hesitating at the edge, as if encountering an invisible wall. These brine pools exist in some of the ocean's most remote and extreme locations, such as the Gulf of Mexico, the Red Sea, and the Mediterranean, regions shaped by ancient geological processes. Their salinity can be up to 10 times that of normal seawater, creating conditions so harsh that few known organisms can survive within their depths. The waters are often rich in methane and hydrogen sulfide, chemicals typically toxic to life, but which, paradoxically, support unique ecosystems. Scientific exploration of these pools began in earnest with deep-sea submersibles and remote-operated vehicles, which have revealed not only the physical properties of these briny lakes, but also the strange, otherworldly life forms inhabiting their edges. Tube worms, chemosynthetic bacteria, and strange crustaceans cluster around the brine's margins, thriving in an environment where sunlight never penetrates and oxygen is scarce. These creatures form the basis of a fragile food web sustained by chemical energy rather than photosynthesis. Yet, despite decades of research, many questions remain. How did these pools form in such precise and isolated pockets? What geological processes keep the brine trapped and stable over thousands of years? And how exactly do these unique ecosystems adapt to the toxic chemistry and crushing pressure of their environment? Some researchers speculate that brine pools might represent ancient remnants of evaporated seas, or massive salt deposits left behind by prehistoric geological upheavals, sealed off and preserved beneath layers of sediment. Others suggest that ongoing chemical reactions between seawater and the underlying rock might continuously feed and replenish these pools, maintaining their unusual composition. But the precise mechanisms remain elusive, a puzzle layered with complexity. Beyond geology and chemistry, the biology of these pools continues to fascinate. The extremophiles found here, organisms adapted to thrive in extreme conditions, push the boundaries of known life. Their existence raises fundamental questions about the potential for life in similar extreme environments elsewhere in the solar system, such as the subsurface oceans of Europa or Enceladus. If life can persist in these dark, saline lakes beneath our seas, what might this suggest about life's resilience and adaptability? Some theories even propose that brine pools may act as natural laboratories for understanding the origins of life itself, environments where chemical gradients and isolated conditions could foster prebiotic chemistry. Could these lakes be analogs to the primordial conditions that allowed life to emerge on Earth? If so, their study might not only illuminate ocean mysteries but also the very genesis of biology. Moreover, brine pools present a paradoxical coexistence. They are hostile and inhospitable, yet teeming with specialized life. Their dense, toxic waters are virtually devoid of oxygen, yet microbial communities harness chemical energy to build complex ecosystems. What evolutionary paths have enabled these organisms to thrive where others perish? How might their unique biochemistry inform our understanding of biology under extreme stress? The pools also raise unanswered questions about their broader impact on ocean chemistry and climate. As sources of methane and other greenhouse gases, do brine pools influence atmospheric processes or oceanic carbon cycles? Might disturbances to these delicate systems, through deep-sea mining or climate change, have unforeseen consequences? Despite advances in deep-sea exploration technology, direct study of brine pools remains difficult. Their remote locations, combined with their harsh chemical and physical conditions, make in-depth sampling a challenge. Each new expedition yields valuable insights, but also reveals fresh mysteries. New chemical compounds, undiscovered species, and strange behaviors along the brine boundaries. As we peer into these underwater lakes, liquid worlds trapped within the ocean, we are reminded of the ocean's boundless complexity and its power to surprise. Brine pools stand as natural marvels, at once alien and intimately connected to our planet's geology, chemistry, and biology. Their silent depths invite us to contemplate life's tenacity and the unknown forces shaping our blue planet. What secrets lie in those shimmering black waters? How much more remains hidden in these pools that defy our expectations? The story of the underwater brine pools is far from complete, beckoning scientists and explorers to dive deeper into these mysterious lakes beneath the sea, where the ocean itself seems to hold its breath, guarding its deepest, most saline secrets. Beneath the ocean's endless waves, where light fades into complete darkness, a world of fire and stone quietly rumbles and shifts. Hidden from view, thousands of undersea volcanoes, some dormant, others startlingly active, shape the very foundations of the planet. These mysterious underwater giants, towering like silent sentinels along mid-ocean ridges and volcanic arcs, are both creators and destroyers, sculpting new crust while stirring ancient geological forces beneath the waves. Unlike the fiery eruptions that captivate us on land, submarine volcanoes present a paradox of power and subtlety. Their lava flows cool instantly in the icy ocean depths, forming strange pillow-like structures that blanket the seabed. Their eruptions often go unnoticed, hidden beneath miles of water, yet they can unleash explosive bursts of energy, shaking the seafloor and altering local ecosystems in profound ways. They are at once invisible and immensely influential, mysterious architects of the deep. Scientists have long studied these underwater volcanoes, deploying remotely operated vehicles and sophisticated sensors to peer into their secretive activity. It is known that undersea volcanic activity plays a crucial role in shaping Earth's geology, producing new crust at divergent boundaries and fueling the hydrothermal vents that host unique ecosystems. Yet, many questions persist. How do these volcanic systems behave over time? What triggers sudden eruptions in these isolated and extreme environments? And how might their activity be connected to phenomena on the ocean's surface or even to seismic events on land? One particularly intriguing puzzle involves the sporadic nature of some submarine volcanoes' eruptions. Some remain quiet for decades, only to suddenly erupt with little warning, producing vast plumes of ash, gas, and molten rock. The consequences can be dramatic, triggering tsunamis, altering ocean chemistry, and reshaping entire marine habitats. But the signals preceding these events often elude detection. Why do some volcanoes awaken unexpectedly, while others slumber for centuries? The chemistry of undersea eruptions adds another layer of mystery. Volcanic gases, laden with sulfur compounds and minerals, are injected directly into the ocean, creating plumes of acidic, mineral-rich water. These emissions feed the enigmatic black smokers, hydrothermal vents that sustain unique life forms in complete darkness. Yet, the full impact of these gases on oceanic systems and global climate is not fully understood. Could these hidden volcanic processes influence broader environmental patterns in ways we have yet to grasp? Moreover, recent observations hint at undersea volcanoes' role in Earth's geothermal energy dynamics. Some suggest that the heat and mineral flux from volcanic activity may affect tectonic movements and the stability of continental shelves. This raises questions about the interconnectedness of geological processes, both beneath the sea and across the planet's surface. Speculation also reaches into more unconventional territory. Could undersea volcanic activity be linked to mysterious seismic swarms or strange electromagnetic signals recorded near certain volcanic regions? Might these phenomena be early warnings of impending eruptions, or do they reveal unknown forces at work deep within Earth's mantle? While such ideas remain speculative, they highlight how much remains to be discovered about these submerged giants. The ecosystems surrounding active undersea volcanoes further deepen the intrigue. Life thrives in these harsh, unstable environments, sustained not by sunlight but by chemical energy from volcanic emissions. Microbial mats, strange tube worms, and other extremophiles inhabit the edges of lava flows and hydrothermal vents, adapting to conditions of intense heat, pressure, and toxicity. What secrets do these organisms hold about resilience, evolution, and perhaps even the origins of life? Studying active undersea volcanoes also presents formidable challenges. The depths and pressures of the ocean limit direct observation, and the vastness of the seafloor makes monitoring these sites a daunting task. Despite advances in technology, many active volcanic sites remain unexplored or poorly understood, their behaviors recorded only in faint seismic traces or brief glimpses from deep-sea submersibles. As our exploration continues, the mystery of these undersea volcanoes endures. They are dynamic forces of creation and destruction, hidden in darkness yet essential to the Earth's geological and biological balance. What unknown processes ripple through their molten hearts? How many eruptions go unnoticed beneath the waves, quietly reshaping our world? The oceans guard these fiery mysteries closely, inviting us to probe deeper, listen more intently, and reconsider what we know about the restless planet beneath the sea. In the silence and shadow of the deep, the story of these volcanoes is still being written, an unfolding enigma waiting to reveal its truths. Beneath the restless waves, scattered across the ocean floor, lie countless relics of human history, shipwrecks that tell stories of exploration, trade, and tragedy. Many have been identified, their names and fates recorded in maritime logs or recovered from the past. Yet among these submerged remnants are vessels whose origins remain an enigma, unidentified shipwrecks that refuse to yield their secrets, their stories lost to time and water. These silent sentinels of the deep beckon us with haunting mystery, inviting us to explore not only what lies beneath the waves, but the depths of human curiosity itself. The ocean is vast and unforgiving, capable of swallowing ships whole and preserving them in its cold, dark embrace for centuries. When explorers and archaeologists descend to these watery graveyards, they often find well-preserved wooden hulls, rusted metal frames, and cargoes frozen in time. Yet some wrecks defy classification. They lack identifiable markings, bear unusual construction features, or are found far from any known shipping routes. What were these ships? Who sailed them, and why do they remain anonymous despite their preservation? One such mystery comes from the depths of the Baltic Sea, where a peculiar wreck was discovered that has sparked debate and speculation. Unlike typical shipwrecks, this structure appeared unusually intact and displayed strange geometric shapes and metallic surfaces unlike any known vessel from recorded history. Its precise age is difficult to determine, and theories about its origin range from a forgotten wartime submarine to more outlandish ideas involving secret technology or even extraterrestrial craft. The scientific community remains divided, cautious to confirm anything definitive while acknowledging the strange nature of the find. Other unidentified shipwrecks are found in the Mediterranean, an ancient crossroads of civilizations where countless vessels have sunk over millennia. Some wrecks contain artifacts or hull designs that don't match any known culture or era, suggesting lost chapters in maritime history. Could these be ships from vanished civilizations, experimental vessels, or undocumented expeditions? The absence of corroborating records leaves us grasping at fragments of a story partially submerged in both ocean and history. The question arises, why do these wrecks remain unidentified? Often, it is because the ocean conceals as much as it reveals. Time, currents, and sediment can obscure identifying features, eroding inscriptions or symbols. Some wrecks may predate recorded navigation, belonging to seafarers whose histories were never written or were lost. Others might have been deliberately hidden, ships used for clandestine purposes, smuggling, or military operations erased from official records. How many vessels lie beneath the waves that challenge our assumptions about human activity on the seas? The mystery deepens when we consider reports from deep-sea explorers and sonar imaging that reveal objects resembling ships or unnatural structures in unexpected places. Some of these discoveries defy easy explanation, with unusual shapes, inconsistent dimensions, or locations far from established shipping lanes. Are these the remnants of forgotten voyages, experimental crafts, or something else entirely? The ocean's vastness and darkness mean many such finds remain only faint outlines on sonar screens, their true nature concealed. Speculation about these unidentified wrecks has, unsurprisingly, drawn fringe theories and imaginative narratives. Some suggest secret government vessels lost during covert missions, their details classified or obliterated. Others propose time slips or anomalous phenomena that might transport ships from different eras or even dimensions into our waters. While these ideas remain outside mainstream science, they reflect the depth of wonder and uncertainty that these silent wrecks evoke. Yet, the search for answers continues in earnest. Advances in underwater archaeology, including improved imaging, robotics, and chemical dating, offer hope of uncovering new clues. Each artifact, plank of wood, or fragment of metal holds a potential key to understanding the past lives of these ships. But the deeper we delve, the more we confront the ocean's capacity to conceal, guarding its secrets behind layers of salt, pressure, and time. What stories have these unidentified wrecks witnessed? Were they vessels of trade, war, or migration? Did they carry precious cargo, or were they empty shells claimed by storms and tides? And how many more lie undiscovered, their existence hinted at only by faint sonar blips or mysterious debris fields? These unknown shipwrecks challenge not only our knowledge of maritime history but also our relationship with the ocean itself. A realm where memory fades, yet traces remain. They invite us to listen carefully to the whispers from the deep, to honor the mysteries preserved beneath the waves, and to accept that some questions may linger indefinitely, resting quietly on the ocean floor, waiting for the day when their stories might finally resurface. Beneath the shimmering surface of the world's oceans lies a tale as old as civilization itself, a story whispered through millennia of a magnificent city swallowed by the sea, lost to time yet immortalized in legend. Atlantis. A name that conjures images of grandeur and mystery, a civilization advanced beyond its era, whose sudden disappearance sparks both fascination and debate. But what lies beneath the myth? Is Atlantis a mere allegory, a cautionary tale from ancient philosophers, or could it be rooted in forgotten history, an enigma waiting to be uncovered in the depths? The earliest known account of Atlantis comes from the writings of the ancient Greek philosopher Plato, around 360 BCE. In his dialogues Timaeus and Critias, Plato described Atlantis as a powerful island nation situated beyond the Pillars of Hercules, widely interpreted as the Strait of Gibraltar. According to Plato, Atlantis was a utopia rich in resources and technological prowess, boasting impressive architecture and engineering feats. Yet, in a sudden cataclysm, it sank beneath the waves in a single day and night. Was this story a historical record, a moral fable, or a blend of both? Over centuries, Atlantis has captured imaginations worldwide, inspiring explorers, historians, and dreamers alike. Some have searched the Mediterranean, the Atlantic Ocean, even as far as the Caribbean and Antarctica for traces of this lost city. Various geological and archaeological sites, ranging from the submerged ruins off the coast of Spain's Doñana National Park to the enigmatic Bimini Road in the Bahamas, have been proposed as possible remnants. But none have been conclusively linked to the Atlantis of legend. From a scientific perspective, the absence of definitive archaeological evidence casts doubt on the existence of a single, grandiose Atlantis. Scholars often suggest Plato's tale was allegorical, intended to warn against hubris and moral decay rather than document a historical event. Others point to known natural disasters, such as the Thera eruption around 1600 BCE, which devastated Minoan civilization on Crete, as possible inspirations for the story of a lost island swallowed by the sea. Yet the story does not end here. The ocean, vast and largely unexplored, hides countless mysteries beneath its waves, including submerged cities and civilizations that challenge our understanding of history. Could Atlantis be a distorted memory of a real place, submerged by rising sea levels or tectonic shifts thousands of years ago. Rising oceans at the end of the last ice age transformed coastlines worldwide, flooding ancient settlements and rewriting maps of human habitation. Are there still clues lying beneath layers of sediment and water, waiting for technology and time to reveal them? Adding another layer to the mystery are fringe theories that speculate Atlantis as a hub of lost technologies or ancient knowledge, possibly linked to extraterrestrial intervention or advanced prehistoric civilizations. While such ideas remain beyond mainstream acceptance, they echo humanity's enduring fascination with the unknown, blending myth with possibility and challenging us to rethink the boundaries of history. The symbolism of Atlantis resonates deeply in human culture. It reflects a universal longing to understand our origins and the impermanence of human achievement. The myth of a vanished utopia warns us of nature's power and the fragility of civilization. It compels us to search beneath the surface, not only of the oceans but of history itself, for truths that defy easy explanation. As modern science pushes further into the deep sea with advanced sonar mapping, underwater archaeology, and submersibles, the quest to distinguish fact from fiction continues. Each new discovery, whether a sunken city, an ancient artifact, or geological anomaly, adds threads to a complex tapestry of human and natural history. But the true nature of Atlantis remains elusive, a shimmering mirage on the horizon of our collective imagination. What if the lost city is not a singular location but a mosaic of real events, places, and peoples woven into legend? Could Atlantis represent an archetype, an eternal story about loss, resilience, and the mysteries hidden beneath the waves? And how much do we still fail to see in the depths, where time folds and secrets sleep? The ocean holds many stories, some told and many untold. Atlantis, whether fact, fiction, or something in between, invites us to continue exploring, questioning, and wondering. What truths remain hidden beneath the surface, waiting for the patient eye to uncover? Gliding silently beneath the shimmering waters of the Aegean Sea, just off the coast of southern Greece, lies a submerged city that whispers secrets of a civilization long swallowed by the sea. Pavlopetri. Recognized as the world's oldest known underwater city, its sunken streets, ancient buildings, and intricate layout evoke a powerful sense of awe and mystery. How did this sophisticated settlement come to rest beneath the waves? And what stories does it hold within its stone foundations? First discovered in the 1960s by pioneering underwater archaeologist Nicholas Fleming, Pavlopetri stunned experts with its remarkably well-preserved ruins, roads, courtyards, tombs, and what appear to be residential and ceremonial structures, all dating back over 5,000 years to the Bronze Age. Unlike many other ancient sites, Pavlopetri's submersion offers a rare, undisturbed glimpse into early urban planning, trade networks, and maritime culture in the ancient Mediterranean. How advanced was this city, and what role did it play in the broader tapestry of human history? Scientific investigations have revealed that Pavlopetri was once a thriving coastal settlement. Rising sea levels and seismic activity, however, led to its gradual sinking, transforming a bustling city into a watery grave. Modern mapping technology, including sonar and underwater drones, has uncovered a complex, grid-like city plan that rivals those of ancient cities on land, highlighting remarkable engineering skills. Yet, many questions remain. How did the inhabitants adapt to the environmental changes that eventually claimed their home? Was the submersion sudden or a slow, creeping process? And what daily lives did the people live before the water closed over their world? The preservation of Pavlopetri is extraordinary, Unlike terrestrial ruins exposed to centuries of weathering and human interference, these submerged structures have been shielded from many erosive forces, allowing archaeologists to explore architectural details and artifacts that speak to a sophisticated society engaged in trade and cultural exchange. Pottery shards, tools, and even possible burial sites have been recovered, hinting at complex social and religious practices. What connections did Pavlo-Petri have with other ancient civilizations in the Mediterranean and beyond? While much of the research focuses on tangible evidence, there remains an air of enigma around Pavlo-Petri. How much of the city lies yet unexplored beneath the sediment? Could there be undiscovered relics or inscriptions that rewrite parts of Bronze Age history? Some speculate that the city might have been an important maritime hub, linking trade routes across the ancient world. Others ponder if the ruins might contain clues about early urbanization and human responses to climate shifts and geological upheaval. Beyond the strictly archaeological, Pavlo-Petri raises philosophical and existential questions about human resilience and impermanence. What does it mean for a city, a civilization, to vanish beneath the waves? How do such losses shape collective memory and cultural identity across generations? As the ocean reclaims what humans once built, it preserves and erases history in equal measure, blurring the line between discovery and mystery. Speculative theories occasionally emerge around submerged cities like Pavlo-Petri. Some suggest the possibility of advanced, forgotten knowledge encoded in the ruins, ideas of ancient engineering prowess, or even lost civilizations that predate recorded history. While these notions remain outside mainstream academic consensus, they reflect our enduring fascination with the unknown depths, not just of the sea, but of time itself. Technological advancements continue to push the boundaries of what can be uncovered beneath the ocean. High-resolution 3D mapping and underwater archaeology hold promise for deeper understanding. Yet the fragile nature of such submerged sites demands careful stewardship. How will future generations balance exploration with preservation? And what new stories will Pavlo-Petri reveal as we refine our tools and methods? As we peer into the underwater streets of Pavlo-Petri, the city feels both timeless and fragile, a silent testament to human endeavor and nature's unstoppable forces. Its stones, submerged yet steadfast, ask us to look beyond surface appearances, to listen to the stories carried in currents, and to remain open to the mysteries still hidden beneath the waves. What other lost cities and civilizations might rest beneath the oceans, their histories waiting patiently for rediscovery? How will our understanding of the ancient world evolve as we continue to explore these sunken realms? The sea keeps many secrets, and Pavlo-Petri is a haunting invitation to dive deeper into the past, to seek out truths that refuse to be forgotten. As the icy winds swept relentlessly across the Arctic Ocean, a solitary silhouette emerged through the fog, a spectral reminder of a bygone era. The SS Bechimo, a rusting, steel-hulled cargo ship, became an eerie icon in maritime lore, earning the haunting title of the ghost ship that refused to sink. For decades, this vessel roamed the frigid seas, appearing and vanishing in mysterious fashion, baffling sailors, explorers, and scientists alike. What secrets did this drifting ship hold? Why did it seem impervious to the forces that claim all vessels lost at sea? Built in 1914 in Sweden, the Bechimo was a robust cargo steamer designed to navigate the treacherous Arctic waters, transporting fur pelts and supplies between remote northern trading posts. Its early years were marked by routine voyages in a harsh environment, but its fate changed dramatically in October 1931. Caught in pack ice near Alaska's coast, the crew abandoned the ship after attempts to free it failed, and the vessel was deemed lost. What happened next, however, transformed the Beichimo from a typical shipwreck into an enduring enigma. Despite being deserted and left to the merciless Arctic, the Beichimo did not sink beneath the waves as expected. Instead, it was repeatedly sighted drifting, sometimes intact, sometimes partially damaged, across hundreds of miles over the following decades. Stories of encounters with the ghostly ship circulated among indigenous Inuit communities, whalers, and explorers. Some described it as eerily silent, its decks empty, yet it remained afloat, as if possessed by some inexplicable force. How could a ship, abandoned for years and battered by storms, continue to resist sinking? Over 20 reported sightings of the Beichimo were documented between 1931 and 1969, with attempts made to salvage the ship on several occasions. Yet, each effort ended in frustration as the vessel slipped away or was found adrift again. Theories abound. Did the ship's robust steel construction grant it extraordinary durability? Was it aided by the unique properties of the Arctic ice and ocean currents? Or did something more mysterious keep it afloat? A silent sentinel in the frozen wastes? Maritime experts suggest a combination of factors: the ship's design, its relatively shallow draft, and the pack ice acting as a natural barrier against sinking. Yet, the persistence of the Beichimo in such a hostile environment defies simple explanation. How many other derelict vessels vanish without a trace, while this one repeatedly re-emerged, haunting the polar horizon? Could there have been undiscovered modifications or hidden buoyancy aids? Or did the harsh environment simply conspire to preserve the ship's integrity far longer than usual? Local folklore adds another layer of intrigue. Inuit oral traditions speak of spirits and guardian entities associated with the Beichimo, attributing supernatural qualities to the ship. While such stories reflect cultural interpretations rather than scientific evidence, they underscore the profound impact this drifting relic had on those who witnessed its ghostly presence. How do human stories and legends intertwine with the facts of maritime history, and where does one end and the other begin? The Beichimo's drifting journey raises compelling questions about survival and abandonment. In a way, it became a metaphor for resilience and impermanence, a vessel caught between worlds, neither fully lost nor truly found. Its story blurs lines between human endeavor and nature's unpredictability, inviting us to contemplate the forces at play beneath the ocean's surface and within the vast expanse of polar seas. Though the Beichimo was last officially sighted in 1969, its fate remains unknown. Did it finally succumb to the icy depths, or might it still drift somewhere, waiting silently beneath Arctic waves? The mystery endures, inviting explorers, historians, and oceanographers to ponder the ship's journey and the secrets it may carry. What lessons might the ghost ship hold about the fragile boundary between human ambition and nature's dominion? Could there be other ships, stories, or phenomena similarly lost to time, yet waiting to reappear? As the Arctic ice shifts and climates change, what new discoveries await beneath the frozen waves, and what truths remain hidden, cloaked in silence? The tale of the SS Beichimo reminds us that even in an age dominated by technology and knowledge, the ocean retains its power to surprise and mystify. It stands as a quiet enigma on the edge of human understanding, a drifting echo of the past that continues to haunt the vast, unyielding sea. The ocean is a vast and silent expanse, where countless stories lie buried beneath waves that seem eternal and impenetrable. Among these submerged mysteries, the disappearance of the USS Scorpion stands as one of the most haunting enigmas of the Cold War era, a naval tragedy wrapped in layers of secrecy, speculation, and unanswered questions. How did a nuclear-powered submarine, one of the most advanced vessels of its time, vanish without a trace in the depths of the Atlantic? And what truths might still be concealed in the silent abyss? The USS Scorpion, a skipjack-class submarine, was launched in 1960, embodying the cutting edge of American naval technology. Sleek, silent, and deadly, it was designed to patrol and protect U.S. interests during a period marked by escalating tensions between superpowers. On May 22, 1968, the Scorpion sent its last routine message while returning from a deployment near the Mediterranean Sea. Shortly thereafter, it disappeared somewhere southwest of the Azores, deep beneath the Atlantic Ocean. Despite extensive search efforts, the submarine remained lost until its wreckage was found over a year later, broken and scattered on the seafloor nearly 10,000 feet below the surface. Official investigations pointed to possible mechanical failure, battery problems, or an accidental torpedo malfunction. Yet, the precise cause of the Scorpion's sinking remains elusive, shrouded in ambiguity. The Navy's final report offered a sober assessment but left many questions unanswered. How could a vessel so technologically advanced succumb so quickly and catastrophically? Was it a tragic accident, or was there more at play beneath the waves? As with many Cold War-era incidents, the disappearance of the USS Scorpion invites deeper contemplation, especially when considering the cloak of secrecy that surrounded the submarine's missions. Operating in a theater rife with espionage, underwater cat-and-mouse games, and covert operations, might the Scorpion's loss have involved clandestine encounters or incidents classified beyond public reach? Was it possible that the submarine was engaged in sensitive intelligence gathering or involved in underwater confrontations with rival powers? Speculative theories have flourished over the decades, fueled by the dearth of transparent information. Some suggest that the Scorpion might have been sabotaged or accidentally attacked by an allied or enemy vessel. Others propose a catastrophic failure triggered by onboard weapons or reactor issues, potentially hastened by rushed Cold War demands. Could the wreckage's scattered debris field indicate an internal explosion or violent implosion under the crushing pressure of the deep? Or might other, less conventional causes be responsible? Secrets that remain locked in classified vaults. The location of the wreckage itself adds to the intrigue. Found on a steep slope of the mid-Atlantic ridge, the site's geological instability may have played a role, but does it fully explain the disaster? The Atlantic Ocean's depths are still largely unexplored, and the seafloor in this region is a complex landscape of underwater ridges and trenches. Could shifting tectonic plates or underwater seismic activity have contributed to the submarine's demise? If so, how do these natural forces intersect with human technology and the limits of engineering? Adding another dimension to the mystery are accounts from former naval personnel and whistleblowers, some of whom have hinted at undisclosed incidents or unexplained phenomena linked to the Scorpion. While none of these claims have been officially corroborated, they underscore the enduring enigma surrounding the submarine's fate and the extent to which national security concerns may have shaped the narrative. Beyond the technical and political questions, the disappearance of the USS Scorpion resonates on a human level. 53 crew members were lost with the vessel, sailors whose lives ended far from shore, in the crushing darkness of the ocean's abyss. Their families sought answers, yet the ocean held its silence, offering only fragments and shadows. What thoughts and fears did those aboard the submarine face in their final moments? And how does the ocean, vast and indifferent, become both a grave and a guardian of untold stories? The story of the USS Scorpion is emblematic of the ocean's dual nature as a realm of both discovery and loss. Despite decades of technological progress and deep-sea exploration, the sea remains an arena where mysteries persist, where human endeavor confronts natural forces far beyond control or comprehension. The submarine's disappearance prompts reflection not only on Cold War history but on the broader themes of secrecy, risk, and the fragile boundary between life and the fathomless depths. Today, as submersibles and underwater drones increasingly probe the ocean's dark corners, the wreckage of the USS Scorpion remains a silent sentinel on the seafloor, holding its secrets close. What further insights might future explorations yield? Will new technology finally unravel the true story behind this Cold War tragedy, or will it continue to elude definitive explanation, like so many mysteries of the deep? As the ocean keeps its watch over the lost submarine, it also invites us to ponder the complexities of a world hidden beneath the waves. A world where science, history, and human experience converge in quiet, unfathomable depths. What truths lie buried there, waiting patiently for the light of discovery to reach them? The mystery of the USS Scorpion reminds us that, even in an age of information, the ocean remains one of the last great frontiers of uncertainty and wonder. The ocean's depths have long been a realm of silence and shadows, a place where humanity's greatest machines can vanish without a trace. Decades after the mysterious disappearance of the USS Scorpion, the ocean once again claimed one of its own, leaving behind a haunting puzzle in the modern age: the disappearance of the Argentine submarine San Juan. In an era of advanced technology, satellite surveillance, and global communication, how could a state-of-the-art submarine simply vanish beneath the waves? What lingering questions does the San Juan leave in its wake? The San Juan was a TR-1700 class diesel-electric submarine, commissioned in the mid-1980s and considered a vital asset to Argentina's naval capabilities. Sleek, silent, and designed for stealth operations in the South Atlantic, it carried a crew of 44. On November 15, 2017, the San Juan set out from the port city of Ushuaia, embarking on a routine patrol mission along Argentina's southern coastline. In the early hours of November 15th, the last communication was received: a brief report of a minor electrical malfunction. After that, silence. Search efforts began immediately, with the Argentine Navy joined by international teams from the United States, Russia, and other countries. Satellites scanned the vast ocean surface, sonar-equipped vessels combed the seafloor, and remotely operated vehicles, ROVs, descended into the abyss. Despite an unprecedented multinational rescue operation, the San Juan seemed to have vanished without a definitive trace for days. Then, on November 17th, a series of unusual acoustic signals were detected by the U.S. Navy's underwater listening network. The Argentine Navy reported that these could be implosions consistent with a catastrophic event on board. What exactly happened beneath those cold, dark waves? The mystery deepened when, nearly a year later, the wreckage of the San Juan was discovered more than 900 meters beneath the surface, scattered across the seafloor near the continental shelf. The images sent back by ROVs revealed a vessel broken into several pieces, its hull crushed under the immense pressure of the deep ocean. Preliminary investigations pointed to an explosion, possibly triggered by a malfunctioning battery. Yet, many questions remained unanswered. What caused the initial failure? Why did the emergency systems not function as intended? Could the crew have sent distress signals that went undetected? While technical failures provide a plausible explanation, the story of the San Juan is far from straightforward. The modern submarine is a marvel of engineering, equipped with multiple redundancies designed to ensure crew survival in emergencies. How, then, did everything go wrong so swiftly? The reports of acoustic anomalies hint at violent implosions, suggesting that the vessel's hull was compromised rapidly, leaving little chance for the crew. But was this failure due purely to mechanical causes, or were other factors involved? The region where the San Juan disappeared is known for complex underwater topography and occasional seismic activity. Could a natural event, perhaps a submarine landslide or underwater earthquake, have played a role? Could the submarine have collided with an unknown underwater object or terrain feature, causing critical damage? Alternatively, given the secrecy often surrounding military submarines, might there have been undisclosed activities or encounters that contributed to the loss? Public speculation inevitably surfaced around these questions, sometimes veering into conspiracy theories or claims of cover-ups. Yet, the truth remains elusive. In a domain where silence is as much a tool as any sonar or weapon system, the ocean keeps its own counsel. What conversations took place in the final moments aboard the San Juan? Were there unseen struggles or heroic acts hidden in the darkness? The disappearance of the San Juan is a sobering reminder that even in the 21st century, with all its technological advances, the deep ocean remains a frontier fraught with danger and mystery. It also underscores the fragility of human life and endeavor when confronted by nature's immense, indifferent power. What lessons can be learned from this tragedy? How might future technologies and protocols prevent similar losses? Moreover, the San Juan story invites reflection on the broader mysteries of the deep sea, the uncharted territories, the unknown risks, and the silent tragedies that may go unnoticed beneath the waves. What other secrets does the ocean guard, hidden beneath layers of pressure, darkness, and time? As the sun sets over the South Atlantic, the waters that swallowed the San Juan lie calm and unyielding. Somewhere below, the wreckage rests, a solemn monument to those lost, and a lingering enigma for the world above. What will it take to fully understand the final moments of the San Juan? And how many other stories lie submerged, waiting for discovery, or destined to remain forever silent? As we shift our gaze from the haunting silence of lost vessels to the eerie creatures that dwell in the ocean's darkest recesses, we encounter a phenomenon that challenges our understanding of life itself, creatures that thrive where most life cannot. Among these are the so-called zombie worms, enigmatic organisms whose existence unfolds not in the vibrant shallows, but in the crushing depths of the abyss. These bone-eating worms, scientifically known as osedacs, have baffled marine biologists since their discovery, revealing a bizarre survival strategy that blurs the lines between death and life beneath the waves. Imagine the ocean floor, far beyond the reach of sunlight, where the cold and darkness seem absolute. Here, where skeletal remains of whales and other marine creatures settle, these worms make their home. At first glance, they resemble thin, translucent tubes sprouting feathery, bright red plumes, an almost alien visage in a landscape defined by decay and silence. But it is what lies beneath these delicate structures that captures the imagination, their unique ability to bore into bones and extract nutrients directly from the fat and marrow inside. The story of the zombie worm begins in 2002, when a deep-sea research expedition off the California coast discovered these strange creatures colonizing whale bones. This revelation overturned long-held assumptions about deep-sea ecosystems. How could life sustain itself in such an environment where no plants grow and food is scarce? Osedacs offered a new chapter in oceanic survival, relying not on sunlight or traditional food chains, but on the remains of the dead, turning death itself into a source of life. Biologists quickly realized that these worms lack mouths and digestive tracts. Instead, they harbor symbiotic bacteria that help break down the complex compounds within bones, facilitating the worm's nutrition. Their roots penetrate deep into the bone's porous structure, secreting acids that dissolve the hard tissue. It is a chilling but fascinating adaptation, one that raises profound questions about evolution's ingenuity and the mysterious niches life can occupy. Yet, the enigma of the zombie worm extends beyond their feeding habits. Where do they come from? How do their larvae find and colonize bones scattered across the vast ocean floor? And why have such creatures remained hidden from scientific discovery until the 21st century, despite the centuries of marine exploration? These questions hint at a broader mystery of the abyss, a realm so vast and inaccessible that even today much remains unknown. The presence of Osedax challenges traditional views on decomposition and nutrient cycles in the deep ocean. They accelerate the breakdown of large animal remains, influencing the distribution of nutrients and energy in these remote ecosystems. But some researchers speculate that these worms may do more than just recycle bones. Could they be part of a complex web of life, interconnected with other deep-sea organisms in ways we have yet to understand? Might their unique biochemistry hold clues to novel compounds or survival strategies that could inspire scientific breakthroughs? As investigations continue, some fringe theories have emerged, pondering the possibility that these worms represent a form of extremophile life capable of surviving conditions analogous to those on other planets or moons, such as Europa or Enceladus. While speculative, these ideas invite us to consider the deep ocean not only as an isolated ecosystem, but as a natural laboratory for understanding life's potential across the cosmos. Despite our growing knowledge, the true extent of Osedax's role in the ocean remains clouded in mystery. Their population dynamics, reproductive strategies, and interactions with other abyssal creatures are still largely undocumented. Are there variations among species in different oceans? How do environmental changes, such as ocean acidification and warming, affect these delicate organisms? And, most intriguingly, what secrets do their unique adaptations hold about life's resilience in the face of extreme scarcity and darkness? In the vastness of the deep sea, where human presence is fleeting and sporadic, the zombie worms quietly continue their work, decomposing bones, recycling life, and surviving in a world few have seen. They serve as a stark reminder that beneath the waves, mysteries abound, and that life, in its infinite forms, often defies our expectations. As we ponder these enigmatic creatures, we are left to wonder, what other marvels and puzzles await discovery in the ocean's abyss? What undiscovered life forms, with equally astonishing adaptations, inhabit the shadowy realm where the sun never penetrates? The story of the zombie worm is far from complete, a chapter in an ongoing saga of deep-sea mysteries that science continues to explore. And so, with curiosity as our guide, we dive deeper into the unknown. The vast and uncharted depths of the ocean have always captivated the human imagination, not just because of what we know exists beneath the surface, but because of what remains hidden. Creatures, phenomena, and enigmas so elusive, so incomprehensible that they have eluded science for centuries. Perhaps the most awe-inspiring of these mysteries are the giant beings that, while whispered about in sailors' tales and ancient myths, remain largely out of reach for modern science. Despite our advances in technology and deep-sea exploration, there are giants lurking beneath the waves, beasts so large, so strange, and so elusive that they defy our understanding. For centuries, explorers have scoured the oceans in search of these unknown giants, only to encounter mere fragments of evidence. An eye-catching silhouette in the distance, a cryptic sonar reading, or an unexplainable surge in water pressure. Yet, even with the most advanced deep-sea cameras and remotely operated vehicles, ROVs, these colossal creatures remain more a legend than a reality. and our understanding of them is as murky as the waters they inhabit. From the monsters of folklore to real, documented sightings, there is a long history of mysterious ocean giants whose existence seems to slip through the fingers of science, remaining just out of reach, always just beyond our grasp. One of the most famous of these oceanic giants is the colossal squid. Larger and more elusive than the infamous giant squid, the colossal squid has been found in the deep, cold waters of the Antarctic. Reaching lengths of up to 40 feet, this elusive creature has intrigued scientists and inspired countless theories. With eyes as large as dinner plates and tentacles that can extend over 20 feet, the colossal squid is a wonder of evolution, a behemoth in the depths. However, despite the occasional discovery of a dead specimen, live encounters with the creature are rare. Researchers have struggled to learn much about its behavior and biology, and some have even speculated that much of the colossal squid's biology remains undiscovered, suggesting that the species may harbor capabilities or behaviors that are still unknown to science. While the colossal squid is undoubtedly a remarkable creature, it represents just one example of the unknown giants of the deep sea. In the same way that we still struggle to fully comprehend the colossal squid, there are other, even larger mysteries. Creatures that live in the most inaccessible parts of the ocean, where the pressure is too great, the darkness too absolute, and the conditions too harsh for most life forms to survive. These creatures might be far larger than any squid or shark we've documented, and some speculate that they may exist beyond the current reach of our technology. One such mystery is the phenomenon known as the deep sea hum, a persistent, low-frequency sound detected by underwater microphones around the world. First recorded in 1991 by the National Oceanic and Atmospheric Administration, NOAA, this mysterious sound, dubbed the UPSWEEP, has been described as a series of rhythmic, rising tones that echo through the ocean. Despite years of research, scientists have yet to pinpoint its source. Some theories suggest that the sound may originate from underwater volcanic activity, while others speculate that it could be the call of an undiscovered giant creature. The hum is not limited to just one location, but appears to emanate from multiple points along the ocean floor, some as deep as 3,000 meters below the surface. Could it be the result of some massive, yet to be discovered species communicating or moving through the depths? It is in this realm of the unknown where some of the most tantalizing speculations arise. In recent years, there has been increasing interest in the theory that unknown giants could be found in the deep, vast chasms that lie at the very bottom of the ocean, far beyond the reach of human exploration. With oceanic trenches like the Mariana Trench plunging deeper than Mount Everest is tall, these regions remain largely unexplored, and the creatures that might inhabit them are equally mysterious. Could these unimaginable depths be the home of creatures far larger than anything we have ever encountered? Creatures whose size, shape, and behavior would defy all expectations? One of the most intriguing and speculative ideas surrounding these unknown giants is the possibility that certain species of massive, ocean-dwelling creatures might have evolved to survive in these extreme depths over millions of years. The theory is that these creatures, given the immense pressure and lack of light at these depths, would develop extreme adaptations to thrive where most other organisms could not. The darkness, the crushing pressures, and the eerie stillness of these depths create an environment where only the most extraordinary creatures could survive, and possibly grow to monstrous sizes. Some have proposed that these unknown giants could be related to creatures such as the ancient Leviathan or the mythological sea serpent. Throughout history, sailors have reported sightings of enormous serpentine creatures with vast bodies and terrifying power. In the modern era, some scientists have speculated that these sightings might be attributed to giant deep-sea creatures that have remained hidden from human view due to the inaccessibility of their habitats. Perhaps these creatures have simply evaded discovery because they live in the deepest trenches, and any glimpses of them are fleeting, occurring only when the creatures approach the ocean surface. In the world of marine biology, there are still many mysteries to uncover. Among the most profound is the question of how large creatures might have evolved in the absence of the sunlight that most large animals require. Could it be possible that large creatures like the ones described in ancient texts, giant serpents, enormous sea monsters, are simply remnants of an earlier era? Creatures whose size was an evolutionary advantage that has since become obsolete. Alternatively, might they be creatures adapted to living in perpetual darkness, in environments where little light penetrates, and where their sheer size is necessary to survive the extreme pressure and scarcity of food? Despite these questions, there are still no definitive answers. We know little about the true nature of life in the deep ocean. And as deep-sea exploration continues, we are constantly confronted with more unknowns than certainties. The elusive nature of the ocean's giants raises an even more fascinating question. How many undiscovered species of enormous size are waiting to be uncovered? Could there be massive fish, mammals, or even cephalopods hiding deep in the ocean's unexplored regions, yet to be captured on film or cataloged in scientific records? The ocean's unknown giants are a reminder that even in an age of technological advancement, much of the world beneath the waves remains a mystery. While we have mapped the ocean floor more than ever before and identified some of the largest creatures that live within it, there are still countless unknowns that lurk just beyond the edge of human knowledge. As we continue to explore these depths with greater precision, will we find that the ocean's true giants are far larger, far more complex, and far more elusive than we ever imagined? The quest to uncover the ocean's secrets is one that will likely never truly end. New discoveries, new technologies, and new theories will always propel us further into the unknown, unveiling one mystery only to reveal another, even greater one. And while we may one day answer the questions of the ocean's unknown giants, there will always be a lingering sense that the true nature of the deep remains just out of reach, hidden in the unfathomable depths where science has yet to tread. As we peer into the abyss, we are left to wonder, what might still be lurking, waiting to be discovered beneath the waves?